I don't think we have an amazing track record at identifying life that demands our attention and moral consideration. Of course, we can improve our material world, but the mind space has no limits. In a world in which you could live a lot longer on simulated or emulated time, and you could just have experiences much faster, much richer, you can live all the worlds and all the lives that you can currently make out, and then some. So that, I think, is something that is truly inspiring. I actually found Foresight because I was really into cryonics. How amazing would that be if you actually had someone that was like out for a considerable amount of time and that you could then later on reanimate? That would be just mind-shattering.
My guest today is Allison Duettmann, the CEO of the Foresight Institute, a nonprofit backing frontier technology for the benefit of life since 1986. Foresight runs grants, fellowships, workshops, and other programs across AI, biolongevity, molecular nanotech, and neurotech. Allison also founded the Existential Hope movement. She co-authored Gaming the Future, a book about civilizational scale cooperation. She studied philosophy and public policy at the London School of Economics. She's also a venture partner at Mythos Ventures. And I believe she's one of the best people in the world thinking deeply about the future, how to coordinate humanity to achieve good outcomes, and working practically today to accelerate the technologies and adoption that will get us there. So Allison, thank you so much for being with us today.
Yeah, thanks. This is a beautiful spot. I'm excited to be here.
Great. Let's dive in. What is existential hope?
Well, first I should say, I'm glad they described it as a movement. I'm not sure if I could call it that yet, but we're definitely picking up people along the way. And I think it's mostly just because if you look out there, the current media landscape still is filled with doom. That's to some extent due to media bias, like it always sells to have very jarring scenes to really like get people thinking about like worst case scenarios. And to some extent that's evolutionary too and exacerbated by the media. But nevertheless, if you look back into our past, there used to be a time when there was very ambitious, positive sci-fi, or when there was any sci-fi at all, really that was new and that really enabled people to look further. And so I think when you query people that have actually invented amazing science and technology, or any other products that we rely on in our civilization, like what got them started, it's often something like either it is a sci-fi book that they read early on, and it's often like very similar books, and they're old, and there's none of them like it anymore. Or it's something like a concept that they just couldn't get out of their mind anymore, that didn't exist yet, but they try to bring it into being. Michael Nielsen from Astera calls it a hyper-entity, which is basically a concept that is so powerful that it can manifest itself into existence. And so this existential hope, I guess, idea is mostly that we can focus all we want on the futures that we don't want to have, and we can focus a lot on the paths that we don't want to go down on. But unless we start thinking about where we actually do want to go, it's going to be very unlikely that we're going to end up anywhere good, because we can just avoid, but never actually get anywhere where we do want to go. There's a lot more to say about it. We're not trying to be prescriptive about the future. It's not like we're laying out this one path and now just like, that's the roadmap, let's go. But I think what we're trying to do is get people to think about for themselves what a good future would look like, because it's probably very different for me than for you. I'm very eager to dive into different concepts of utopias. There's various different ones, from periodotopia to protopia to variotopia, but without getting all conceptual, like I think a good future might look different to you than to me. We want to have people explore that again, think about this again, and lean into this, and then hopefully get inspired to build some of these positive worlds instead of some of the worlds that we currently are running from.
Why do you think that media and public narratives tend to skew so dark and dystopic?
Well, I mean, partially it's this evolutionary bias. We really need to be wary of the futures that, not just the futures, the risk that we want to avoid, the threats in our life, right? Otherwise, you wouldn't have made it very far, I think, in our ancestral environments. And that's fair enough. I'm not trying to say that we shouldn't be focusing on the risk at all. I think another one that's exacerbated by the media is just that, sex sells, but also what really sells is like pretty gruesome crime stories and, horrible imagery and kids being abducted. All of this is triggering this evolutionary part of ourselves that is like just trying to survive. But we're now in a civilization where we don't only need to survive anymore. We definitely do need to still do that. But in addition, we now finally have the ability, the technology, the civilizational know-how, ability to cooperate, to kind of lift our gaze a bit and think about, well, where could we be going? What would it mean to live in a universe where we don't kill ourselves? How could we get there? What technologies might we want? What societal structure might we want? And that type of thinking is not really evolutionary ingrained in us. So we actually need to train it and we need to think about doing it. Otherwise, we'll forget and we'll just end up in the rat race of zero-sumness and collectively avoid different parts of futures that others would want.
To make it more concrete, what are some example visions of the future that you're thinking about? Like, give us a sense of the scope of the distribution.
Yeah, I mean, you could think along different axes. One axis is the technological vantage point, where that's also something, I guess, that's more foresight aligned, but where you think about what technologies might be possible, and then not only individually, but also how do they interplay with each other. So for example, we were founded on this vision of advanced molecular nanotechnology. The idea is that you can build with a lot more precision in an automated way, and through that build much smaller, build with a lot less waste, build things that we currently cannot build new structures, build new devices with new properties that might be stronger, that might be more durable, that might be less wasteful. You could clean up the environment, you could clean up all the mess that we've made as 20th century and 21st centurization that we have become. And that's just nanotechnology itself, right? There's a lot more potential benefits even through that, like including nanobots in your body. What could that mean for longevity and health? Then there is longevity biotechnology as a field in itself that has grown a lot since I started at Foresight. And there you could think about what would it mean to live healthy, long lives. And usually when we think about longevity, people think about, well, I would just be like my grandma or, like my parents over 70, 80, 90. Unfortunately, they are not who they used to be. And people are not very excited about extending that, but that's not what it's about. It's about actually having the virality, having the mental capability, having the lust for life that you had in your early days, and trying to either restore that or preserve it from the get-go. And then there's various other technologies like neuro, the one that we're going to talk about, but they're all kind of interrelated in the sense that ultimately if you want to live a long life, you need good neurotechnology or neuroscience, because it's the brain and it's you that we're trying to preserve here. It's not just your body. And nanotechnology could help with all of this. AI, obviously. I think the interesting kind of connection is that AI might be the engines of design by which we can really design what we want to build in the science and technology space. And then you have the engines of creation, which might be things like nanotechnology, for example, or also biotechnology in some level that can rearrange and manipulate and better edit the physical world to take these designs and implement them into reality. So I think that there's a long way to go in terms of positive visions on the science and technology side. And then there's the whole other societal spectrum, that you could go down on, and various different ways that we can just be more peaceful, collaborate better, in more positive some ways, keep our options open. That's the Biotopia idea of we don't really know where we want to go yet, but we probably want to preserve optionality, freedom of information, free speech, the ability to actually have epistemically good conversations. There's a prototopia idea from Kevin Kelly of probably we want to get all the way to utopia, but we want to get to just doing it a little bit better every day. And that's how civilization has evolved. And look where we are. It's pretty great when it's great. So there's different societal concepts too of how can we cooperate better and do so in a way where we create a world that is better for more people by their own standards.
What are some of the responses you've seen so far from people that come in touch with existential hope? Either the visions that they've articulated prompted by you, or in maybe their reactions to the idea space that you think are helpful in kind of generating a trajectory. Meaning, from my perspective, the existential hope movement is a really wonderful counterbalance to the darker side that comes from the existential risk landscape, where it was very useful and valuable to frame existential risk so that we could identify a range of problems and avoid them. But it also had the side effect of creating too much doom narratives that then also triggered maybe the EAC, effective accelerationist landscape as a counterpoint. But I feel like existential hope is similar counterpoint, but very different in kind of quality and perspective and vision. And so I'm wondering, what are some of the ideas that you see percolating through the community, or the kind of outcomes that you hope to instill?
Yeah, I mean, I think you're totally right. Once you set a pretty radical vision out there, then there's usually a counter radical vision. And then there's the EA / or more the AI safety doomer movement that was eventually birthed. Then as a response, you had the EAC movement. And now you have the DEAC movement in the middle, which is more defensive, decentralized, differential acceleration. But I think in general, if you go back to the existential risk framing, I think it's a really important framing. That's the basics, right? It's just that we survive. Individually, maybe that would be nice, but also as a civilization. And then the same people that were really at the forefront of making the existential risk movement big and writing very eloquently about it, Toby Ord and a few others, they were also the ones really championing the concept of existential hope at the beginning. So it's not one or the other, but they were basically pointing out that the same way that we were talking about an existential risk, basically an event after which I think they call it the expected value of the universe would be much lower. Then an existential hope event would be one where the expected value of the universe would be much higher. So like an event after which you'd be pretty sure that the universe would be amazing. That's a very tall order. I think Toby Ord had something like emergence of life as one existential hope event.
Or like going from unicellular to pluricellular organisms.
That's a tall order, you know. But nevertheless, I think we can also think about smaller existential hope events in our life. And nevertheless, I think the direction is a different one. You know, it's just like focusing also on what you do want. And things that I've kind of like seen percolate out of this is theme of world building as one in itself, where rather than trying to be prescriptive about one future is like the main point is mostly just trying to inspire people to think about what a good future would look like for themselves. And I do think that when we have this world building competition and have had it now for quite some time, and the worlds that come out are so different. I think we have a gallery of over 100 different worlds or something, and they're all incredibly different, but they're all super creative and kind of amazing. And I think it's mostly this process of engaging with the future in a positive manner that we hope to see. And then hopefully through that, you also get inspired to actually like get engaged and build more of these things. So ideally, what we want to see is not just like having people imagining these worlds, but then, for example, one of them was pointing out a future key societal coordination framework where like you actually have automated prediction markets that run on everything in the future and like have much better odds at like what's actually going to happen. Maybe some of it also AI automated. And then where humans come in is like we would still vote on like the future that we would want, but we'd have much better information. And so not that this was inspired by that world, but there is a future key organization out there now, et cetera. So I think like ultimately we want to have some kernels of ideas and then have people actually like go out and build them. Like fiduciary AI is another idea that I think would be awesome. Like an AI that actually runs locally, has your best interest at heart, can go out, reduce search costs, coordinate with other AI agents on your behalf, negotiate with them, and ultimately come to agreements. Like there's a variety of different things that were nothing stopping us from building this really, apart from like imagining it and then going out and doing it. And so we're just hoping to inspire a bit of that.
Do you have plans for maybe turning some of those visions into more evocative narratives, like movies or short film or like things like that that could like help? Because there's something really, really powerful about certain pieces of media and art that communicate the idea space so well to lots of people.
Yeah, we actually have a small movie that's coming out soon. It's an animated movie. It's on the concept of like tool AI and like basically, because sometimes, especially in our communities, you tend to think that we really only need AGI and then that will solve everything else. But ultimately, I think why we're excited about AGI is because it can do so many things that will benefit humanity, right? In an ideal case, right? And so there's nothing stopping us from creating some of those benefits sooner. I do think that ultimately AGI would be a very powerful technology, but ideally we should already start thinking about today, you know, how can we actually use AI to improve people's lives in a very visceral manner, right? That would, I think, also alleviate some of the concerns that many people in the public have about AI. And so being a lot more concrete about that would be useful. And so we made a short movie about that. And I think in general, media creation is great. It's getting easier with AI. Thanks. And that would certainly be useful. We had a meme prize the other day where people actually submitted AI-generated content, videos, memes. And the winner was a Voices from the Future conversation where people reflected back on what it was like to live in the present when you did not have longevity yet, or at least like LEV, like longevity escape velocity, meaning when people would still die. And in that future, they wouldn't really age if they didn't want to, et cetera. And so they were reflecting back on like how cruel the present is compared to a future in which you have health available and accessible. And that one, and that is very much worth watching, I think. So that was all AI generated, and it was really quite beautiful. So yeah, I do think media is important.
Yeah. Talk a little bit about AI and maybe the last 10 years. Foresight has been at the forefront of lots of frontier tech, both thinking ahead, 20, 30 years and beyond, and helping people, scientists and technologists and policymakers reason about the future. I think Foresight was super ahead on AI and the AI landscape. How have you seen that kind of unfold over the last, 10 years or so, where like these communities together made a whole bunch of predictions that are now starting to happen at scale? And a lot of the world is unfolding as a lot of people predicted. It's very different to be living it than just, be reasoning about it into the future. What are some of the things that like the landscape ended up different? And how does that make you think about like the next, 5, 10 years?
Yeah, I mean, I should say I've only been with Foresight for a decade, and it's now our 40th anniversary, so I'm a newbie. But with that disclaimer out of the way, what attracted me to Foresight was the early archives, and it was the fact that, like 40 years ago, they had discussions about the future of AI in tandem with various other emerging technologies. And back in the days, I think people thought that nano would come earlier than AI, or at least like people in the broader AI nano community that existed at the time. That hasn't panned out to be the case at all. Mm-hmm. So for now, it really looks like AI is going to be there first. But the two, as I had already pointed out, are so deeply entwined. Like better AI might lead to better modeling and simulation, which might lead to better nanotechnology in building, which might lead to better chips, better like other infrastructure that would better energy that would allow you to build AI faster. So they're all kind of very deeply intertwined. But nevertheless, it looks like AI will be first. I think we can agree on
totally.
that.
Yeah, for sure. Yep.
So that's something.
It will have to be very different for that for the nanotech. Just
who knows? Never say never.
Before
it's possible. It's possible. I do think that ultimately, though, interestingly enough, like the main bottleneck to doing things will become the physical world, right? Like very soon, especially when we can automate a lot. There'll be this AI overhang, and so thinking now about what kind of projects, what infrastructure, what coordination we can put in place to actually tackle some of the physical world so that we can, once AI starts to automate a lot of the non-physical world, we can actually get going on the physical world, because that's going to be the rate limiting factor to progress very soon. Yep. And nanotechnology is the best way to actually rearrange the physical world and edit it the way that will be helpful for civilization. So
how far away does nanotech feel today? I mean, it still is the sort of thing that a lot of people talk about as being many decades out, but it could be a lot closer.
Yeah, I mean, I wouldn't say many decades, because I'm not sure what is many decades out at this point.
It gets extremely difficult to reason about, 20 years out into the future. But yeah, I would say that today, if you think about where the capital investment is going, I don't think that the large pools of resources take seriously the idea that you could come up with way of manufacturing chips and beyond with, atomically precise manufacturing techniques to then generate, again, all the chipsets that you need, or like the data centers, or like the robotics, or like new materials, like all of this kind of stuff.
Yeah, I don't think anyone's really taking it seriously. Yeah. Still not. I think we're maybe perhaps still one of the only organizations out there that is like making a case for it, like seriously, I guess. If there are others, I would love to meet you.
But Foresight has like a great track record of building the communities. I mean, like the archives also have like the period where Foresight was hosting all of the space-oriented meetups, 20 years ago or 25 years ago, that like Elon and Steve Jurvetson and others used to go to. And then they were talked about, oh, great, like the thing we need to do is get reusable rocketry. And then Elon's like, okay, great, I'll go do that, right?
And he did.
Here we are.
And he did. I guess for nano, let's see. There are some projects kind of like going into the right direction, either from the bottom up, in the sense that like there's progress on some of the technologies and paths that we might want to use to get there. There's also new paths emerging, like there's the protein engineering route, there's the DNA nanotech route. There's still the, STM, AFM, actually like placing atom by atom route. Microscopes are getting better. We might be able to do it eventually. So that kind of scientific stack, or the tech stack, is emerging from the real actual bottom up. And at the same time, you also have people trying to build smaller from the macro scale. That's not really going to get us quite to nano, but there's an ARIA program, I think, on manufacturing abundance that's interesting. I think they're really at least grappling with the idea of like what it means to manufacture better. There is Neil Gershenfield at MIT is doing interesting work on Fab Labs. I think he was one of the creators of Fab Labs. And so he's trying to just like get the scale down and down and down and down and automate Fab Labs a lot more, so that we can like maybe get eventually from 3D printing to like printing smaller and smaller. Again, we're not going to get all the way to printing nano that way, maybe. I should never say maybe. But I think people are trying to grapple with the material world a little bit.
Shifting into the other parts of AI that might, unfold over the next 5 to 10 years. What are some of the things you're excited and, existentially hopeful about?
Well, I think one thing where people weren't quite sure about at the beginning, and we're still not quite sure of how AI is going to play out, I think, is it going to be more singleton-like, or is it going to be more decentralized? And so those are, of course, like big suitcase terms. When Superintelligence was published, the Nick Bostrom book a while ago, it laid out this kind of like recursive self-improvement world where over time you might have more economies of scale and like basically dynamics that would push very much progress towards possibly creating one super intelligent entity, whether that is like one AGI system or whether it's a system by like controlled by like one entity that would very quickly be able to outcompete and just scale faster, build up more of a delta and more of a lead towards other AI efforts, and then kind of like outrun eventually, just because recursive self-improvement and scaling might eventually lead to such big benefits. Even small advantage points might matter so much because you can build on them, right? That you can just outpace your competitors eventually. So that's one path, right? How AI could be going. And then another one is that actually maybe that's not going to work, because maybe what we'll find out is that local knowledge is very hard to come by, that there are these long tail problems, that you want actually specialized, super intelligent agents that can focus on one specific task really well, and then instead of scaling them all the way up to a generalized system, you want to enshrine them in some broader economy or ecology of other specialized, super intelligent agents that do one thing really well. And then you have this kind of Borg mind or multi-agent collective intelligence cooperative layer that, negotiates, manages resources in between. And so that's more kind of like the civilization and the economy that we currently see, but hypercharged.
And certainly the current trajectory of the development of AI favors this distributed approach in that.
You think so?
Well, so far in that maybe we needed the mega scale data center to do the training, but the way in which the inference of transformers ended up working out is that it is very difficult to create that one singleton type entity. And it's a lot easier to have millions of small, pretty intelligent systems. Now, they are all parting from the same model, but the fact that you can go from one model to millions of agents, and that's the easier thing to do than to kind of harness the computing power for millions of agents and make one ultra powerful singleton, is like a weird path dependent thing that comes down from like how the semiconductor industry ended up like making chips and how data centers got shaped and so on.
I've definitely heard like, the Sutton's bitter lesson of just like actually just, throwing compute at something and like scaling works pretty well. There's still that theory. I think I just went to a talk where the narrative was more that like test time compute and scaling works so blatantly well that we haven't really like got the final benefits out of it that we can. Maybe scaling can go a lot further. And at that point, you just need a lot more compute. Actually, how the architecture eventually looks like, that might still be a different question, of course, but generally you need a lot of compute.
Yeah.
And so,
totally.
Whoever is building it still needs a lot of resources.
Yeah, so you might have like these like mega scale resourced training environments. I think it is surprising and counter to a lot of the sci-fi that you would end up with millions of separate instances that all part from the same model, as opposed to like, the classic example from a lot of sci-fi is you have like one single ultra intelligent machine that everyone sort of talks to. DeepThink is a good example, or like HAL, or lots of examples and narratives. And it just turned out that like after you spend your billions of dollars of compute, you end up with like a terabyte of parameter weights, and then you can run them. And that's like a weird outcome.
That is true. But then there's also differences between like, who controls the AI versus what's the architecture of the AI, right? And so you could even have like perhaps like one very powerful company controlling the AI, while the architecture itself might still be like a bunch of different agents or something, like a mixture of experts like working together.
You have millions of agents, but they're all controlled by,
it's possible.
AI Inc.
Yeah, I mean, AI Inc. Put your favorite AI org in there. So I think like those types of dynamics are really interesting to watch. I don't think we know yet where we are at. I appreciate that there's risks and benefits on both sides. The obvious one on the decentralized being, you by giving a lot more people a lot more capability, you also proliferate risk and the ability to cause civilization scale damage in the form of bio or cyber weaponry. And then the downside of the more centralized vision is, of course, like that has not historically worked super well. You have single points of failure. They are vulnerable to attack. They're vulnerable to corruption and, maybe even accidents. And ultimately, you might have some dynamics that come with that might be pretty autonomy restricting eventually. So, there's ups and downs to either side, but I do think that the kind of camps have evolved. Back in the days, people just cared about AI and they were like cared about AI safety. But now I think we really see different kind of streams evolving that are more along the lines of like, we're trying to chart a decentralized path. And this is where we think it's actually going to be likely and normatively better to go. Or versus like, no, it's actually just going to be scaling all the way and it's also safer that way. So different camps. And it's very interesting to be at the front row of all of this and see how it's going to play out.
How do you think about AI life? Because I think in all of these camps right now, most of them are kind of united on the front of AI should only be a tool and it should definitely not be a form of life or a form of having individual agency. But to me, it seems like that's unlikely to pan out in the long term and also kind of short-sighted too, in ways that leaning into charting a path for like a very good protopic coordinated path to building digital life might be like a good trajectory. I don't know if how much you think about this. And
yeah, I do actually.
Landscape.
I do think about it a lot, and I think it's probably prudent to start thinking about it now. I don't think we have an amazing track record at identifying life that demands our attention and moral consideration. Yeah. Neither on the human level nor on the like other sentient creatures around, aka other non-human animal level. So I do think that we are just not historically great at it. So I don't think it's too early to think about. I think in general, there are definitely camps that are trying to avoid these sentient AIs. Then there's others that are really trying to bring them about. Ultimately, I do think that if we have incredibly intelligent entities that develop their own goals, that pursue them, that have longer context windows, that have the ability to access more resources, that are getting more agentic, more creative over time, they will have these final goals. But through that, they might develop instrumental goals, like things that they need to do in order to get to the final goal. And then over time, these instrumental goals, might develop into things that you curtail. And by curtailing, you might actually like harm or at least very much curtail that entity. And I think that ultimately humans, we kind of develop the same way. We had some goals that we wanted. Then we had like instrumental goals along the way. Eventually, these instrumental goals also to some extent evolved into felt goals, like love, for example, right? Like love, very evolutionary beneficial. But love is kind of important to us now, It's like the thing that still makes people go around. And so these kind of
and it's like for many people, it's the top reason for fulfillment and for existing in life.
Yeah.
Entirely.
Yeah, and also for misery. So these instrumental goals are now felt goals. We feel them. Like that's the best way to make them instrumental and useful. So I don't think we can really rule that out. There's nothing in my head that makes me think that this is not a possibility. And so I do think because these systems currently in the way that they're constructed are so different to us. So for example, they can copy in the way that we're currently building them. They don't necessarily need to rely on procreation to procreate or on sex to procreate. So they will have
like
kind of
copy and paste the weights and replicate them.
And there they are. So they will have different felt goals very likely, right, than us. And so it's going to be very hard for us to intuit what they are. And so I think we need a better science around it. And there's amazing orgs that are working on that. Ilios in the Bay Area, for example, they're trying to kind of like create a better science of human and machine consciousness, and like actually trying to like create evals based on different theories of sentience and consciousness, and try to evaluate different models according to how they're faring, not just on one theory of consciousness eval, but across a spectrum of consciousness evals, because everyone has their own pet theory of how consciousness works. And so rather than picking one, maybe like you have a breadth of them. And so I do think we need to get started on it. And I don't think we have an amazing track record that should make us super optimistic that we're just going to wing it and it's going to be fine.
Very much agree. This is a really great segue into neurotech. How do you think about these kinds of questions in terms of organic brains and so on? Like one part is trying to understand the sentience of artificial intelligent systems, but we barely understand consciousness or perception or qualia in our brains and our own mind. Do you think that some of those evals that people are making might end up translating into testable predictions in organic brains?
I mean, hopefully, right? Like, I mean, for a while, I think there was a hope that we can basically get better at understanding current biological systems and then through them develop good evals for AI systems. And I guess we're doing that to some extent because that's what evals are somewhat still based on. But on the other hand, we haven't really done that for animals all that well. So now the hope is the opposite of like, maybe by creating good evals for AI systems, we can also apply them to other biological creatures, including humans and others. So I do think either way of whether it's evals or not, we're going to learn a lot because we have to differentiate and distinguish ourselves eventually from them. We have to ask these hard questions of like, and how far are these? And we already are. Society is definitely asking themselves that. People that get upset when they have their access cut off to, like an older version of OpenAI's or Anthropic's latest model, they are upset, and like companies are probably not going to do that again without warning people. We're already encountering these problems in the wild. So one one way or the other, we're going to like have to make up our minds about this. It's philosophy with a deadline, how Nick Bostrom calls it. And so ideally we have good theories around it before we're going to go all by memetics and intuition and, like just, it's going to be complicated either way. But
maybe thinking about neurotech much more broadly, what are the things across the field that you're very excited about or you think have like an enormous amount of promise, either short or medium term?
Well, I think like at Foresight, at least we're like, there's a lot we find interesting from like also more of a far future perspective. There's like, I guess, 3 buckets. One is the neuro AI lens of like actually finding out a lot more about how the brain works to inform and inspire different ways of building AI system and vice versa. The other one is the brain-computer interface space where we have this amazing capability potentially to like restore, augment function in significant ways. And then the third bucket of things is the emulation layer, which historically has been perhaps like a little bit more sci-fi, but I do think there's projects and people that are making good progress on that. And there the goal is like actually like, can you emulate model organisms or like potentially eventually a human? And so those are the 3 buckets, I guess, that we broadly care about. I'm happy to
let's go.
talk more about individual ones.
Each one, Let's dive into the first one.
Well, the neuro AI one, I think, is mostly from like an AI safety lens, and like we are actually not funding or pursuing all that much work in that, but I still think it's kind of interesting. There are other amazing efforts, for example, from the Amaranth Foundation, who put out a lot on the neuro AI landscape and what we can actually say about interpretability by learning from human interpretability for AI systems. Also, not just on the safety side, but can we build better models by relying more on how the brain is working? Those are all, I think, really interesting questions. And I think we can just learn a lot more vice versa on the both interpretability side, but then also on the how does this actually work side, right? In both domains. And that's, I guess, partially what like Neurops was doing at the beginning, the conference. Now it's like very, very AI heavy, but it was really this interconnection between neuroscience and AI.
Yeah, it's like the science of how neural networks will work and like the math and systems of larger and larger scale networks, the science of intelligence in a sense.
Yeah. So really interesting field, I think. And there's a lot of academic research also in that area that's interesting because it's like quite theoretical. You don't need a ton of resources. You need some compute resources, but it's not like, it doesn't require you to build new hardware devices all that much. And the other one, brain-computer interfaces, that's one where we've just seen like an explosion of amazing projects, many of them in the Bay and many of them with various different near-term and long-term use cases. But I think in general, like we have a human brain, it's working so-so. Definitely working better at the beginning of your life than at the end of your life. And it's definitely working better for some people than for others. And so you could think about it, are there actually folks that we could like lift back to where much of humanity is through brain-computer interfaces? And they have very different shapes, forms, sizes, levels of invasiveness, but like broadly.
It's kind of like the restore use cases of like, hey, somebody has, due to a genetic disorder or some accident, have lost function in part of the nervous system. So either I don't know, they lost the ability to see or hear or speak.
Yeah. And, the idea here would be to restore that, to actually allow them to do that. And I think that is probably the one that people most come across on the internet. And I cannot watch it without having my eyes water because I think those use cases are just so hope inspiring. It's hard to even talk about it.
Yeah, it's just so impactful. Like it's come up in a few of the episodes so far. Where like this one example of a woman turning on a cochlear implant for the first time and hearing, or some other examples of being able to go from somebody with Parkinson's and shaking to then.
Suddenly holding, being able to move around in your own kitchen, right? Like, so if anyone listening to this has not seen those, it's just really worth like just Googling it. And
we'll put the links in the description. And there's great news there in that the last 10 years have seen incredible advances in the manufacturing and building of the devices and getting them through clinical trials. So we've gotten to talk to a few of the people at the forefront of building these. So like these are going to be in market like now or very soon, like in single years.
I'm pretty grateful actually that FDA and like some of these other regulatory orgs have moved fairly fast on some of those. So that's been cool to see, which is not often the case.
Or faster than in other cases,
Not quite fast enough as we might like, but there are also, of course, some serious downsides to consider. But nevertheless, like it has really improved people's lives. I'm just hoping that they become a lot more accessible and like just get rolled out fast.
How do you think about those devices extending into beyond kind of restorative use cases into improving lives or kind of enhancing capabilities? Like one part is restoring vision, but like the same kind of device can enhance it. Like you can go from a limited part of your visual spectrum into like a much larger, like being able to see like eagles or see like very far away or see night vision? Like, I don't know, is that kind of stuff that you think about or Foresight thinks about?
I mean, who wouldn't want to have that, right? I think as a kid, you're most likely to think about this, of just like, how do other animals perceive the world, and like how much better are they at smelling or and other factors. Like, I think definitely like the ability to be able to do these types of things much better would be great. The ability to just remember better. Like, if I could remember as well as when I did my A-levels, that would be amazing. And now, of course, as you age, that's not going to get better. And so I think, uplifting folks that are more on the like older spectrum, but at the same time also, why only start there? I would love to remember a lot better than I did, like even better than that, right? Like there's nothing that is necessarily stopping us.
You could like remember all of Wikipedia or like remember.
There might be some things I want to black out.
Yes.
and
selective memory.
Selective memory, I think it also serves a point, right? Like we're just not built to have everything in our mind at all time, but the ability to tap into it easier and the ability to grow the muscles to at least remember the things you really want to, like that would be great.
Or learn new things really fast.
Yeah, learn new things. I mean, that kind of skill acquisition kind of comes also hand in hand with the memory part, right? Like we really want to be a lot better at acquiring skills. To some extent, people are trying to do that through things like memory palace and like better ways of learning skills and stuff. But
install the driving skill application or
learn
to ride a bike.
I think the sky's the limit here.
Play piano, yeah.
I would love to. I'm not musical, but it's the one thing that I would love to do where I'm totally suck at, and I would just love to be able to have that module in me. I think another one is, I think we've seen some amazing things, what things like TMS can do for depression. And it's not just TMS, there's other modularities as well, like transcranial magnetic stimulation. There's other ones as well, but like TMS, I think is only still FDA approved as like the last resort for depression after you've exhausted all SSRIs, etc. And now you have people, I think like Tim Ferriss and a few others that are just kind of going out on a limb and trying to fund more TMS accessibility and availability because it has just proven, especially when paired on specific supplements that he goes into at length in some of his writing on this, that it has proven to be able to do the work of like years of therapy if you do it right in the span of a few months, and like when done in this accelerated enhanced version, maybe even the span of a few sittings. And that would be great. I've seen loved ones with debilitating depression, and that's been really tough to watch. And at the same time, you can think about, could this be better for cognitive performance? There's a few people that have tried to use that and you can also think about, could it be better for like modulating other parts of your life, right? Like sometimes I'm not the person I wish I was. I have acrasia, or like weakness of will. I sometimes, think I want other things than I do. And so like actually modulating your mood, being able to like perceive when something is actually like bothering you, and be able to kind of switch out of it, maybe meditate, maybe, do something else, leave the room rather than engaging with that path would be good, like sleeping better, sleeping easier, basically understanding what your mind and body tells you. I'm usually at least totally numb to it. I'm very unintuitive, non-perceptive person. Being able to understand your own mind and your body better and listening to some of these signals would be awesome. And then there's a lot more, like being able to interface both with computers and also with other humans just much more deeply, like the kind of bandwidth of communication. We have these mics, we are doing a podcast. It requires a lot to set all of this up, which I'm very grateful for. And of course, ideally, I think that when you know people, you can mind meld with them already a little bit because you have so much shared context, right? But in other scenarios, like, having just a lot better bandwidth communication with other humans might eventually be possible, right? Like you can just share context a lot easier. And then likewise, just being able to process and have access to all the information that's actually online in a computer, being able to get your queries out faster, being able to process information faster, creating those feedback loops of like actually becoming a lot more operating at a much higher bandwidth than we currently can with our fingers or something. Sometimes I find a difference between what I'm thinking and what I'm trying to write down is very hard to accept.
Yeah. This is also an area where sci-fi examples where BCIs are used to expand horizons or like explore the mind more or kind of generate like new kinds of experiences. Like there's, like the Nexus trilogy where people are able to like link together and kind of have shared experiences and in kind of like very deep ways. Or there's less BCI and more like connectomics, but like in Permutation City, people are able to like mind meld in various different ways and so on. So I don't know, what of those have you like thought about or explored or are excited about? Or
yeah, I mean, now we're talking more like real speculation, but I think that's ultimately some of the most exciting things when I think about what could a future look like. Of course, we can improve our material world, but the mind space has no limits, or as far as we can tell, right? And like one book that I love is Permutation City, and even though many people think it's a dystopia, I actually think it's very utopian. I think you should have to read it and decide for yourself.
I agree. I strongly agree on the utopia side.
Right?
Yeah.
So first of all, like it's more an emulation book, but it goes from this like premise of like at the beginning, someone's kind of emulated against their will, and then without wanting to take all the story away, but like ultimately they are in this kind of like very rich emulated world where they have these shared experiences with some of the other emulated minds that come along. They can mind meld in extremely deeply ways to share a lifetime in what probably in objective time outside looks like seconds or minutes or something, but they have known each other for eons and, really are able to share a life with someone. I think something that I sometimes struggle with in the default world is just that, sometimes you have a deeply transformative experience and you're trying to explain it to someone else and it's just not cutting it. You just can't explain what just happened, but you're really longing to. And likewise, when people that I love explain to me things, I'm like, I wish I had been there. I wish I was in your mind. I wish I could really comprehend what this means to you. And that sense of like deep, it's much more even than empathy, but that sense of like shared experience, ultimately it's like not being lonely, right? It's like being more than one, like having a shared experience with someone else, or many people for that matter. It's something that I'm deeply missing, I guess, and would be amazing to have. Likewise, I think if you think from a productivity layer, being able to actually like collaborate with others, in a very deeply meaningful, almost Borg-like manner, where instead of just sharing your experience with one, you can share it across different minds, right? You can actually really you should be able to select what you share. Yeah, I don't want to know everything that's going on in your mind. Yeah. Neither should you know everything that's going on in my mind. But ideally being able to kind of have access control and actually share the bits that are relevant for specific endeavors, civilization scale, galaxy scale endeavors that you might want to be taking on with other minds, and then work really efficiently with each other, being able to like communicate and just actually build collectively. That must be something, quite amazing. And that's just in the human world. There's potential other sentient creatures that we might want to understand much better, know what it feels like to be them. I always wanted to feel like what it was like to be my dog. I don't think I ever will, not what it's like to be that dog anyways. But I think the ability to actually mind meld across different species and also have an ability through that to develop a deeper sense of empathy for them and compassion and just, be able to live collectively better lives with each other on planet Earth would be kind of amazing.
You already touched a little bit on through the Permutation City story into like the third category, which is kind of the emulation simulation area. What is an emulation or a simulation of a brain system? How does that work?
Yeah, I mean, there are different approaches and opinions differ on that front. But in a nutshell, I guess, one could say it's something, like actually creating or recreating a copy of an individual's brain in an ideal sense that both has structure, like a similar structure representation of what the original brain looks like, but then also functionally is equivalent enough, at least, to the original brain that you actually end up with something that is like more or less looks like and behaves like the biological version, but now it's just on a different substrate, aka it's possibly like a digital mind. And so, usually that is the connectomics route that, people are favoring and pursuing here. So you actually slice very thinly a model organism's brain and then actually image it bit by bit and then stitch these different images together so that you can actually create a connectome, like a map of what the brain looks like. At that point, you really only have, even if that all works, which is a very complicated process and it's definitely we're not there yet for humans, but even if that all worked, you would still have to get function out of it, right? Or even if you had a map, trying to actually read anything useful out of that, trying to predict how that organism will behave, trying to also see whether it's remotely similar to how the original would have behaved, that's a very tall order.
Concretely, the process is you have an organic brain, you're trying to image it and extract the wiring diagram of all of the different organic neurons and how they communicate. And if you can replicate that with high fidelity or high enough fidelity, then you should be getting same exact functional output. And so you can make a high fidelity enough copy in a digital environment and you run it, then you should have a perfectly preserved snapshot of that person.
Yeah, that's the theory.
The theory, yep.
And so far, I guess, like we've definitely done C. elegans.
Yep.
We've
done the snapshot of C. elegans.
We've done the
simulations
snapshot.
are not.
We've done the snapshot. Yeah, and that was my part. Like, I guess the kind of functional piece is actually kind of difficult, the emulation piece. But we've definitely done the snapshot, and that we've done decades ago. Then recently, like, we've made real strides on the fruit fly and like the FlyWire project, amazing project. I'm not sure if you've had anyone on there from that.
Not yet, but we will.
Okay, you will. Great. So they can tell you a lot more about the specific details of that. But like, that was a real breakthrough that made hope and optimism inspiring. People are trying their hand at a mouse. Different parts of a mouse, maybe like stitching different parts together. That's a much taller order. And then a human is still, that would be the holy grail, of course, and like, just because it's so difficult and like time and cost intensive to actually do the slicing that might be required for that, to actually do the imaging, to do the storage for humans, like, because human brains are just so much bigger and more complex than a mouse, let alone a fruit fly, that all of the difficulties of a fruit fly just grow in complexity. So it's just a very, very hard problem still at the scale. At that point, then you'd still need to map it, right? Yep. And the mapping is, I think, really where things get totally astronomically more complicated.
Yeah, so we were talking about connectomics work and extracting like wiring diagrams of organic brains, and it's not clear like what kind of connectivity between neurons actually matters in carrying the signal. So we don't know how to construct the simulations yet to like effectively work. Where do you sort of see the field and what are the needs?
Well, different people are trying to work on different parts of the problem that you just mentioned, anything from the annotation layer, from the annotation problem to bring down the cost of like the actual imaging and that process of the actual imaging, right? Maybe we can have better microscopes for doing so, etc. So I think there's different pieces of the puzzle. Like, I think the compute problem, honestly, and some of the storage and the actual part of like, once you have that, what do you actually do with that? How do you run it long term to have like more of those and to store the information properly is also something that we haven't really solved yet. But I think in general, like, we also need more shots on goal, and we just generally need more projects, because there are so many different research efforts that are trying to do a part of it. There are now, luckily, FROs, that are trying to like actually create better tools that other projects can use. Boyden Lab has created a bunch of tools that other projects have used. So definitely people are trying to create more tooling for the ecosystem at large. But the kind of patient capital and the efforts with the ambition of actually trying to see a project from start to finish, actually see it through and trying to create an entire emulation. We've seen a few of those on like a national level scale or like a collaboration between different universities, but like having more shots on goal like that and actually allowing people the time and the experimentation and hopefully coordinating between them to create these more mega scale projects. That I think I don't see as much of yet as I would like to. We have different people building different tools, different people are having different approaches. Now we finally see some tools that can be reused. We see some shots on goal, but I think we need more than that.
For the people listening, like, if you could wave a magic wand and summon assistance from the internet, like, what are the things that you would point people towards? Is it just being able to form the capital required to like do the engineering projects? Is it, hey, actually, no, we need founder level talent to be able to construct the engineering machinery, like recruit the people, form the team, like run the thing? Or is it, hey, you need more scientists digging into the problem space and kind of thinking about it at a concept level? What are the requirements?
I don't know. I mean, how powerful is this magic wand? Yeah. I mean, I should say that, like, I'm not a scientist in any of these domains, but like from a field building perspective, I do think we need a lot more talent. We need talent that also has a level of ambition to want to go there and like work on these hard problems. I think one thing that you often see in academia is it's like excellent work that's coming out of it. You can usually be sure like this is actually great. But I think one thing that's a problem of the academic incentive structures, it goes by like, how can I like advance this field a little bit forward? How can I, write a grant application for a specific domain that is like good enough that it gets likely funded, but I'm also sure enough that I can actually make some progress here where I can publish afterwards, right? And so I'm not saying everyone's doing that. There are a few rogue scientists and researchers that are very much just having some build up enough credibility to be able to do really ambitious work. This is also not their problem. Like, it's a problem of the field and the incentive structures that there are. But to some extent, we need to think like the opposite way around of just like, where do we want to go? And then think about what needs to happen before that, what needs to happen before that, what needs to happen before that. And so I think like having this kind of shot on goal mindset rather than the like, let's advance where we currently are, like one step at a time, is kind of a problem that like A, requires a mindset shift, but then B, it requires the funding behind it. And it's not a pot of funding once, because in order to convince some of these people to leave their positions that they've worked 10, 20 years, sometimes longer for, to get, they finally have tenure, and then you're trying to convince them to put it all on the line to join this ragtag team of people that are trying to have a shot on goal on emulation. That's a crazy ask for anyone, especially for these people. So you need to signal that this project is sustainable enough that they can actually put their career on the line for that, right? And the scientific ecosystem, for better or for worse, but also for good reasons, is like extremely unforgiving in some of these areas. And so like these people putting their careers on the line, like this needs to have real signal. And if you want to get the best people, and for this type of stuff, you need to get the best people, because generally not that many people are thinking about this type of stuff generally. And the ones that do have a lot to lose, right?
This feels similar to the BCI space pre-Neuralink, right? Like I think pre-Neuralink, there was maybe one or two companies that were kind of chipping away at the problem, but very far away from commercialization. And the appearance of Neuralink as the first extremely serious engineering, very fast-paced project with very large capital, like kind of checked a bunch of like required boxes, opened the Overton window, drew a lot more people into the field, galvanized attention, shaped the first range of devices, popularized the idea, drew a number of people out of academia into the field, and almost independent of whether or not Neuralink specifically with the Neuralink specific devices are the ones that catalyze the BCI landscape, already that effort move the entire field forward massively. And we kind of like need a version of that for simulation.
It also had the benefit of having Elon, which that's just very hard to replicate.
Yeah, but we probably have other people that can make that kind of push.
Yeah, big benefit of having Elon was like you had the network immediately and the kind of signal. If you want to do something ambitious, this is where you go.
Yeah.
And because some people, that I met through the Foresight ecosystem are just like, I did neuroscience because I knew Neuralink was a thing and I wanted to work there, or like I started building devices because I knew I would eventually could maybe get into Neuralink. It's not only like that researchers switch from out of academia there, but like it created this whole new field of people that were just like, I want to do what Elon's doing. I want to be part of that. And, I'll do my best.
There's some piece of this, which is having a very clear sense of how to tell the story publicly, broadly. And we are committed to doing this very credibly, that I think Elon gets, a number of other founders also get it. But this is often not well understood in academia, not well understood in corporate research labs, or maybe more conservative corporations. Like there's just very real and tangible catalyzing value to having singular leaders who understand the problem domain enough, can spell out the vision, can commit to it with the resources, energy, talent required, will form the pieces, and more things can get catalyzed that way. I mean, I think like a smartphone was a version of this. Apple just gung-ho doing it and building the first major scale smartphone, releasing it into the ecosystem, opening the frontier to say, forget about like the keyboard, like a small screen thing, like we're going in this other direction, and then rewired the rest of the phone industry to go in that direction.
Yeah. And I guess like, I think I once saw like a lecture, I think it was Elon at Stanford, where he went deep into Fermi paradox land and was like, because of the Fermi paradox, we need to be a Mars civilization. And because of that, we need things like SpaceX. Because of that, we need reusable rockets. And like really just like started at the like, there's the thing like the Fermi paradox. We need to become interplanetary. We need to go to Mars. That's why we need to do everything else that SpaceX is doing.
Yep.
So I think this type of vision, right? And for Neuralink, it was similar. It was like, there was the AI vision of humans. If we want to be compatible with the long-term future in which AI plays a role, we need to be able to uplift ourselves, improve ourselves, like enhance ourselves, or at least have the option to do that. And so for that, we just need Neuralink. And for that, we need to start at the restoration piece, but then like we need to move ahead. And so to some extent, that sounds crazy. I mean, even SpaceX sounded crazy, but having that vision and being able to actually get that into people's minds in an inspiring way is something that he's been fairly good at.
Yeah. Yeah, and I think there's a range of other founders in the space taking that,
of course,
that view too. I think Max is a good example of starting to push into this direction, where not only did Max help shape the beginning of Neuralink, but now he's pushing the frontier of all of this sensory restoration and pushing into the very high bandwidth BCI type use cases.
Yeah, I mean, he's unapologetically like just doing that thing, and is also a very clear communicator about that. You definitely get that same inspiration, I think.
Yeah, and I think, for our progress to advance faster, more successfully, and so on, we just need more Max and Elon type people that can form these efforts and push them forward? How do we attract or generate more of those people?
Partially, I think it comes from a deep obsession with the future. I think, if I remember, for Max, it also started very early. Like, I think there was rarely ever a time where he wasn't obsessed, I think, with the future. So whenever you ask people what inspires them, it often started pretty early. So you need, on the one hand, like a kernel of this deep want for the future to be a thing and to have the audacity to think that you can have an impact on that. And then you need somehow it paired with a sense of like technical ability to at least figure out what's important and neglected to do there. And then, like, to some extent, that's not always the case, but it definitely helps to have some financial freedom, or at least have access to capital and be convincing enough to attract it, to be able to like push for these visions. And I do hope that at least the last piece, through, you know, some of the writing that we've recently seen out of, like, you know, this third wave philanthropism that might be coming soon, thanks to AI and thanks to some of the, whether it's secondaries, whether it's IPOs, whatever you have in the AI world right now, and the SpaceX IPO, of course, also being a potential factor there, but like people being soon in a position where actually they can put some more money behind that. And we've seen that in crypto as well. Like, and the people that were interested in crypto early and the people that were interested in AI early, first of all, there are sometimes similar people or the same person.
Same people.
And then the second point is like they both, if you're interested in crypto and if you were interested or like early, and if you're interested in AI early, that's usually a pretty good reference class for also being interested in other really interesting things that are very important for the future. And so those types of people, I have high hopes for that a few of them might like branch out and just do something. And we've seen it, for example, Sam Altman, you know, like being an instrumental part in RetroBio, in funding RetroBio and funding Merge, Episteme, like projects like that, right? And so we already see that, and same with crypto, right? So I think that's good. And hopefully in the future, some of that money will end up to these very ambitious
and certainly, I mean, definitely the AI field, because it's so visible and working and so on, has attracted a substantially large number of strong founders to go and tackle a lot of these problems. We're also seeing that in a range of hardware domains now, where 10 years ago, it was extremely difficult, but post the Tesla and SpaceX successes, that generated both a crew of people that either spent time in those companies, learned how to do it, and then went on to build other companies, or where at least the existence proof of Tesla and SpaceX enabled a set of people to form the capital to actually go do it. We now have significantly large numbers of good companies in the deep tech landscape, but somehow I feel like we still need to draw larger numbers of those type of founder type people into the neurotech space, and certainly into uploading, right? Like into connectomics. Like,
yeah,
this is like still.
If the neurotech space is undervalued, then within that, the emulation space is just, I mean, like, I think until a few years ago when we did this emulation workshop, trying to kind of look back at the original roadmap from 2008 from Anders Sandberg, Nick Bostrom, and a few others. At that point, I think we were like 30 people in this like tiny convent-like space in Oxford, and it just seemed like, is there even a there? You know, can we talk about this stuff now? Or is it even at a point where it makes sense to kind of dust off some of the old roadmaps and where we can look at this again? Of course, there has been a ton of progress individually in that. I shouldn't be saying the space. There isn't even like the space yet. But in the space is relevant for emulation. There have been a lot of progress over the last 20 years, even before that. But I think the concerted effort of like thinking about like, could this be a possibility? Like, if so, what would be required for this? You know, what are some of the bottlenecks? I think only over the last maybe 4 or 5 years or something, I've even seen people reconsidering that. And so it's fairly fresh and new, you know, in the sense that people think that this is now a possibility that has been partially inspired because they think that we might need it vis-a-vis AI systems, but also partially just because we now actually might have the tools to make some progress on this, or at least like seriously consider it again. And so I think it's generally a pretty exciting time, but it's very early stages for these areas, and we definitely need talent. Most of the neuroscience space doesn't really think of that area as something that they could be going into that is worthwhile exploring. And so I think there's a lot of education required, incentive structures required, like all the things that you need for starting a field, right?
We talked about some of the how and kind of like bottlenecks in the field and so on. And we kind of touched a little bit on the edges of this, but let's maybe get deep into the why of emulation and simulation, like the amazing upside case here. Like what would it look like to get this right and to be able to actually simulate entire brains?
The space is just so broad. We have on the one hand the kind of like subfield of this could be beneficial vis-a-vis AI systems getting rapidly more intelligent, because in the emulation space, you might have something like an actually human-aligned AI system. In the big if that you get this right and that you get this done soon, you have something that is like an artificial general intelligence that is not based on a totally alien architecture, but you actually have something that is like, more or less like trying to emulate as much as possible, at least how humans work. Humans are not perfectly aligned, but humans are like somewhat aligned, or at least like we know the pitfalls and dangers of humans a lot better than we might know those of alien minds, where we don't really know their motivational factors, etc. And then you'd still have to align like humans and find architectures of cooperation under which these M's could coexist. There's the question of like how compatible or competitive are they even with artificial intelligences? When would they even arrive? Questionable whether that could be done before AGI. But even if it could be done after AGI or like in tandem with AGI, in some manner, you might still want them as a long-term hedge for a long-term future in which you, as someone that is human originating, wants to be competitive or compatible with AI systems or compatible with the future really at all. I never would like to have a future in which that is the only way in which you can exist. I do think that we need that freedom of choice, and ideally we can wall off a garden in which humans can just be humans, those that don't want to be kind of along for the ride. So that's kind of like the sci-fi case and the AI safety case for that. I don't know how sci-fi it actually is, but it's worth consideration. And then, but even apart from that, right, like the emulation cases are really strong. On the one hand, like if we had an actually simulated mind or brain, we could learn a lot about how humans work. What makes us tick, really like understanding humans on a deep, deep level, which might shine more light into the theory of, into the problems of consciousness and sentience. It might provide us with a lot more of an interpretable standard of like, what do different interventions, drugs do to the human mind? Like, how can we actually improve some of the kind of failure cases that we know that are actually like deeply ingrained in the way that our brain is set up, at least for some people, how it's working? Can we like intervene in that very precise level and like actually have a mind that is not like optimized for something external, but like that works the way that we would want, that like is a little bit more reliable at the things that we would want, right? You can actually have this surgical, more than surgical precision of hopefully modulating and helping the brain like live up to some of the hopes and dreams you might have for it. Restorative, but also augmentative. And then there's the whole part that we just explored that is like more long-term in the sense of like, do you want to merge with potential AI systems? Do you want to merge with other humans? If you emulate in a sci-fi scenario, at least it is explored by like Robin Hanson, for example, in Age of M, you could like let emulations run much faster than human brains can, or you could have them run slower than humans. If you want to like extend or contract your subjective time, you could allow yourself to live in incredibly rich virtual environments. And oftentimes people are like, well, but then you would just have these worker emulations and they will all live at subsistence and these automata that produce work for you. But the thing about virtual worlds is that it's not very expensive to make nice ones.
Yeah. Exactly.
So
dramatically cheaper than organic.
Yeah, I mean, this table is like, it's hard to move, it's hard to create, it's expensive.
Yeah,
but like
the energy requirements are like
right?
dramatically different.
Yes, you need compute and you need some good designs. But apart from that, like worlds or the emulation space is your oyster, right? Like you can really emulate a lot easier, amazing simulated environments that you can rearrange the physical world to your liking. And so if we had these emulated minds, it's not clear to me that they would lead a terrible existence because it's just so easy to make them have a good one. And so you just have a lot more space of creating amazingly rich experiences for people, having them like really like experience what it's like to be in someone else's shoes in all the ways that we currently can only like conceive, sometimes in like heightened psychedelic states, maybe like actually intuit or something. But it's just the virtual world is crazily vast.
With your like existential hope perspective, like what is a concrete picture of like awesome future with like digital existence?
Thinking up new scenarios, new environments that you want to explore that like they could either be mirrored on existing worlds or entirely new worlds that you might want to see. So I think the exploratory side is like almost unlimited. On the connectivity side, I think like actually being able to go really deep with the people that you love, like actually be able to like, mind melt, for lack of a better term, with these people, being able to learn a lot, right? Like I remember when there was a time when I was young and I thought I could eventually read all the books that there were or that I wanted. And then, of course, you eventually realize it's totally impossible, right?
I know, that is a crushing moment when you learn that. You're like, wait, hold on. There are more books than I can read in my lifetime.
Yeah. And usually like the more you learn, the more you know that what you do not know, but also the more you know the things that you would like to know. In a world in which you have like close to infinite time, you have all the time, you have the skills, you have the resources, you have also the kind of learning environments to actually comprehend reality and life and other humans, other sentient creatures at a level that is totally unimaginable to us right
this
now.
is a piece I love about Permutation City. Also, like where this is not spoiling anything. One of the characters just can experience a very large array of different lives and experiences and just schedules for himself, like just experiencing all of these different types of things, and like spends entire lifetimes learning how to play a particular instrument and becoming like amazing,
a virtuoso.
And then just goes into like intricacies of like woodworking in this particular way, or like mastery of this like other artistic thing, or like an amazing exploration of all the lives.
I do think that putting my David Deutsch hat on, or Beginning of Infinity hat on, that even then we'll still have the problems that we will make up and compose so many amazing worlds, experiences, and things to learn, that we will still have the problem of like we will never get it all done, possibly. But that's kind of a problem that we have to live with, I guess. That's a pretty good problem to have, And I do remember, like,
as Deutsch says, problems are soluble.
Problems are soluble, and then you create new ones and you try to solve those again, and you create better worlds through that. And we now look at our life from a longevity perspective. There's this kind of like deep sense of almost, sadness for sure, that we kind of have to pick one lane, more or less. I mean, like, okay, if you look at our parents, they really had to pick one lane. They really had lived one life, one possibility. Then we kind of came along and we're like, oh, we're actually going to like do things more open source, and we're going to collaborate a little bit over here and over there, and like we're going to move to different countries, and like, we're going to do a few different studies. And so we are
multiple careers in your life.
You can have multiple careers. So we are already living kind of like more, I think, but there's still so many other careers I would have liked to have, right? If only I had the time to do that, or just like things I would have loved to experience and live. And so I think we have to pick like one narrative arc in our life. There might be different kind of sub-stories or like chapters in it, but it's like this one narrative arc. And in a world in which you could live a lot longer on simulated or emulated time, and you could just have experiences much faster, much richer, you can live all the worlds and all the lives that you can currently make out, and then some. So that, I think, is something that is truly inspiring. And then I think the final enemy is that if you think about super longevity from a biological perspective, if we, let's say, said that we're not going to emulate and we are somehow going to live in our biological bodies for a very, very long time. This is now going into like sci-fi land a bit, but like nevertheless, it might be possible.
Then that far out. Like these days, a lot of people are both making significant advances in biolongevity, but also taking it a lot more seriously. Like it's become part of the public conversation. When we were talking about it 10 years ago and beyond, like you couldn't really use the word longevity publicly that much. People would be like, oh, this is weird, like this is strange. And now it's, in major podcasts, like part of the public conversation. A lot of people want to extend health span. There's still a massive long road to go, but like people are a lot more aware of the problems and working on the challenges and excited for the solutions.
I do hope that that's the way that uploading is going to go. And like in 5 years or maybe even sooner, we're going to sit here and be like, oh, do you remember that time when like that wasn't really like a thing yet? And then at that point, it's so obvious that it would be crazy to do yet another podcast about it or something. So I do hope that we'll get there. I don't think we're that far away from what I think we've recently seen of how the neurotech space has exploded. But nevertheless, I do think what I'm talking about here more is like super longevity. Like now imagine like really living indefinite,
or 200 years,
like much longer, right? Like years. Let's just like put that hat on like and think about it for a minute.
Outlast
you can live
the sun.
Yeah, but like not outlast the sun, but like outlast a lot more, right? Like actually be around for like the next few billions of years. And then eventually you have like something maybe like the heat death of the universe. And like, even if you think about hyper longevity from a truly existential hope perspective, eventually the universe might come to some kind of end, like various different theories of how that might be. But eventually, like, things would just possibly like drift apart, like there's a lot less going on in the universe. And the cool thing about Permutation City is that it kind of, not necessarily has a solution to that, but it's like, it has a pretty good hack for that. And I don't want to take the ending away, but I think if you think about emulated minds and mind uploading, there's just a lot longer in subjective time than you had in a super longevity time in the universe that we have physically, because you can speed up, slow down at your will. So without taking the ending away of Permutation City, but I think the actual ending of it is the thing that actually gives me hope. And if we could do that, that would be pretty awesome.
Yeah. Well, that'll be a great teaser for folks out there.
Yeah.
We'll put the links to Precondition City on the description. Speaking about longevity, real shift in people like now understanding it. Certainly, this is also something that Foresight helped pioneer and help a lot of people think about, like the early cryonics work and thinking the Foresight community helped shape a lot of it. Where is the field now? And well, I guess there's the biolongevity piece and there's like the cryonics picture in terms of how do you avoid catastrophic outcomes in between now and then? How do you do medical time travel? Where is that landscape today? What are you excited about? What are you hopeful for?
Yeah, I mean, first I should say that I actually found Foresight because I was really into cryonics when I was very young, just because I was very disillusioned. Well, first I was very into longevity. I didn't want to die. Then I thought...
Why, actually? Sorry to interrupt you. But
well, I mean, why would you want to... Like, for me, it was more like the opposite. Exactly. I couldn't really imagine... what I thought it was preposterous that A, we had to die, and then also B, that it was just seen as an okay thing or something. Like, there are valid reasons why some people might want to
it should always be a choice.
choose.
And like you have like very, very serious cases where like you want to just end the experience, and like that should be your right. Yeah. But sometimes people talk about it in terms of the opposite. Imagine a world where life is just continuous and it is expected that you would live forever until you don't, or like you would live until you don't want to anymore. And then somebody introduces the concept of like, no, now we're going to start killing everyone after 80 years. And we're going to like introduce a change into society that's going to make your body degrade and decay.
Oh, I have goosebumps when I think about it.
Down, and then you're going to turn into dust.
Yeah.
Oh man. Like
that would be a bummer.
Right?
So it's crazy to think about that could be a world that we'd be in, and then we'd look back on the present in this manner. So whether you think we just have to take the default world as a given and then modulate our expectations based on what's currently possible, then I think framing of like death is fine, let's just make the most of life is fine. But if you actually think like, no, we can actually restructure and modulate the world to match our expectations, then the notion of accepting death is actually like pretty painful, because then you're just like selling yourself short, right? Instead, what you should be doing is to be like, okay, there might be a chance where we can actually extend life a little bit. And like, if so, what would it mean to work on that? And then for a long time, probably nothing would happen. And like, it's just kind of like psychologically very unsafe to take that step, because first you have to accept death is bad. And then you have to accept we don't have a solution for it. Mm-hmm. And that's really hard. And that's kind of where most of the field is in, unless they trick themselves into thinking, oh no, we can solve death easily in our lifetimes, which also some people are in.
From my perspective, like death is good has been like one of the biggest cope mechanisms in human history. We have invented so many narratives about it just to like help us get over the fact that we like don't know how to deal with it, or like we didn't know how to deal with it, and we're finally in the frontier of solving it.
Yeah, there's nothing graceful about aging, really on a biological manner. It just means you're working less well. You're less the person than you used to be or want to be. So
so you were a kid, you didn't want to die. Then what?
Well, then I got into this deep existential crisis of like, well, but I still have to, because there isn't really anything like it right now that's a panacea against like, we don't have to die, no matter what people tell you. It's just like we don't have someone that has lived for 300 years right now around. So then I was like, okay, what else is there? And then I came across biostasis or cryonics. And, I was still in Germany, in Hamburg at the time, and read up on it.
This concretely is this preserving the body and putting it into a near frozen state. Or like, I guess, technically it's not freezing because it's not...
Vitrified.
Vitrified. you want glass, you don't want ice. And you can preserve, as in sci-fi books, you go into like cryostasis and you freeze the processes of the body, you stop, and then later you can rewarm and restart. And so this can be helpful to like avoid disease, if we don't know how to treat a disease right now, like we might be able to know in the future. So if you have like some terminal disease, you can like go into the cryostasis chamber, wait, 5-10 years until we know how to treat the disease, or longer, and then kind of like recover.
Yeah. In theory, at least, you're not really allowed, I think, to curtail your life, to choose cryonics as an option. Nor, I think, would it be super wise to do so right now based on where the science is at, because there's a few companies that are doing the work that they can, and organizations like Alcor, Tomorrow Bio, and a few others. And people are preserved already, including many Foresight people. But currently, like, at least, and again, I'm not a scientific expert in any of those domains, but the way that I read, at least, the level of sophistication that we have in current preservation technology is just like, we might not be all the way there yet, that you have good chances. Like now there's Ralph Merkel, who was an early Foresighter. He always said, if you're on a boat and the boat is sinking, you're either going to face sure death or someone throws you a life jacket. It's still really far away for a rescue boat to arrive, etc. So your chances might still be very slim that you survive, but would you take the life jacket? Yeah. And usually, yes, you would. And unless the costs are enormous, like I think it's still useful to sign up to Cryonics now. And the costs are not ginormous. For many people, you can choose life insurance to actually pay for it. That's how I did it. And especially if you should try to do that young, because the younger you are, the better terms on your life insurance you're getting. And so and you can still, at a later point, decide actually that your life insurance goes somewhere else. You can change the beneficiary of your life insurance later, but you should, no matter what you do, you should get life insurance. Yeah. Because either you might benefit your family from it, or you might use it to pay for your preservation. But either way, like we're just not there yet. That we can
change though, right? Like there's some new companies that
yes, but I'm saying for people that are currently, I think, already preserved, I think we would need to wait longer to rely on more advanced nanotechnology or something like that to be able to, like actually
to put the pieces back together again.
Yeah, like in a way, we just need, like what people think in the cryonics world is just we need to wait longer for them.
Yeah, I do think, in thinking about this, I think it may turn out to be that all those mechanisms ended up working out just fine because superintelligence should be able to reconstitute a lot of these pieces. I think it'll come down to questions around, do you have enough data points to interpolate the human in between?
Yeah, I mean, like how much of a book can you destroy but still decipher the story?
Yes,
right?
exactly.
Like things like that.
Yeah.
And then, of course, this is just like, what is the actually like truly preserving a human as they currently are preserved state of the science? I'm still going to go for it. But then there's a lot of other amazing things happening in between of like, can we just advance the field forward so that at a time in the future, we can actually make sure that the organisms that we're preserving, we can actually prove that we can already reanimate them. And that's what more recent companies are trying to do. They're not necessarily trying to do it for humans right yet, but like for other non-human animals or for like, for organs. And then of course, for the organ case, you have a pretty big use case already because most of the organs, I think currently in the US, don't get to like from the donor to the new host.
Oh yeah.
Not because the organ is bad, but because of the times that it takes to actually allocate the person that they would benefit and then get them to where they're supposed to be.
It's a tragic problem. So like if you have a condition where you need a new organ, a kidney or a liver or something like that, you get put into a wait list. And then because we don't have good organ preservation technology, you basically have to have your operation to get the organ from a donor like a number of hours after their death or their donation, which means that unless a particular compatible donor happens to die close enough to when you need it, if like the timing doesn't work out, then you die.
Yeah.
And it's like this tragic thing. So if we can get organ vitrifying to work correctly, like organ cryostasis to work correctly, that would save a gigantic number of lives.
Actually, I don't know if the organs that are getting from A to B, if they're vitrified, because I thought that you just put them on dry ice or something and try to get them to...
Well, today they put them in dry ice type of environments, but I think the point is like, today you can't do organ banking. Like you can't put them into stasis for...
I see.
Say,
of course, that would be much preferred. Then there's all these other projects of like growing organs in other like animals or, but anyway, that space of synbio is amazing and it's growing and it's wonderful. It's totally sci-fi and otherworldly.
And there's going to be some really good news. I've seen some stuff that is not public yet. Bring all these stories a lot closer real soon.
Well, I'll probably hear it on this podcast, maybe, I would imagine.
Yeah. Less neuro-related, but maybe we'll expand it.
Yeah, sure. I mean, ultimately, those are all continues to make you live and see another day.
Yeah.
But yeah, so I do think that projects like Until, from Laura Deming is a fantastic project in the space where I think if I'm getting the mission correct, and you should just have her on and have her talk about it. But it's really like this ambition of like, we actually want to prove that we can reanimate like model organisms and like eventually like more complex model organisms before we do anything, like afterwards to them. And so how amazing would that be if we actually had, like this would, to me, be worthy of the label of existential hope in the sense of like an event after which my expected value of the universe would go up a lot would be if we could actually reanimate, like basically put down and reanimate a complex animal, maybe even a human, and they would come back. That would be, and I mean, to some extent, we've done that already in the sense that sometimes, we can store embryos for a while, right? So that's great. When we actually declare someone dead later on, they are not quite dead yet. And that time actually from being declared dead to being able to be reanimated, or not being declared dead, but like actually having your organs fail to like being able to be reanimated, that also has grown. So like I think we're making progress there as well. But I mean, in general, like how amazing would that be if you actually had someone that was like out for days, or, you know, for like a considerable amount of time, and that you could then later on reanimate? That would be just mind-shattering news.
And this alone would save hundreds of millions of lives. Even if you discount the long-term cryostasis option, if you had a limit of we're only going to do this for like max 30 years or whatever, this already is sufficient to help save the lives of hundreds of millions of people that die from diseases that become preventable over time. The most shocking way of thinking about this is there's this graph for different diseases where you can see how different interventions, technological interventions that were invented over time, increase life expectancy. The one that I love looking at the most is the cystic fibrosis one, where initially somebody with the condition would only survive a few months to a few years, and then as new technologies appeared, the life expectancy started jumping up into like 5 years, 10 years, 15, 30, 50, and now people, you know, have like a normal life or close to a normal life expectancy. And so if somebody, you know, depending on when you were born, you're sentenced to die at a particular time shorter. And if you could just like walk into a room, freeze, and then reanimate when the disease is now treatable, you have like access to your full life. And like that's gigantic life improvement for the world today that, you know, get that working. I mean, amazing.
I mean, on the one hand, those graphs you said like are amazing to look at. On the other hand, they're so sad to look at.
I mean, amazing in like the shocking ways. Amazing that we figured out how to treat it. Shocking that we aren't solving it faster. And like the potential, if we could just like at least unlock medical time travel, like that would be amazing.
Yeah, and I think also the way that I think I had interpreted some of the untils results recently is that like once you actually get something down to minimum temperature, 30 or 50 years doesn't really matter. Like basically, like I think once you have something preserved, it's preserved. So, you know, like it's not necessarily like after 10 years you have to like look at the clock and be like, oh, we better get going. So I think at some point it just you are preserved.
The technology and the solution might be exactly the same to preserve for 30 years versus 3,000. But question of like, hey, would you like to survive this cancer that is currently untreatable? That's like a much easier question for most people today than like, hey, do you want to live 3,000 years?
Yeah, but I think the question would also be, is that cancer treatable in 3 years or in 3,000 years or something?
Oh, yeah.
You know, like,
totally,
basically, like, but for that, you can have contracts.
That's right. Yeah.
You know, like you don't have to, it's not a one-size-fits-all policy, you know, and like to some extent, I mean, yeah, it's just so intuitive. And I think the big thing in there always when I think about it is just like, right now, I think civilizationally, we're so close to either really break through and become a sustainable, okay, whatever number you want to pick, civilization long term, and like actually climb the Kardashev scales and just create a future that is all the ways amazing that we try to touch on like throughout this conversation already. I remember growing up thinking like, still like reading all this sci-fi and like just being like, wow, one day this might happen. And would I want to be a part of it? But I'd never actually considered that I would. And so now I think we are actually quite close to it, thanks to many of the individual scientific advancement and then AI accelerating many of them. And so I think now it would be extra sad to miss the cutoff because it's really so close. And the cutoff meaning here like the transition into like actually being able to live a very long life if these technologies work out and we don't kill ourselves through an existential risk through AI or whatever. So I think right now it's especially bittersweet to think about that there might be one of the last generations around that might ever have to go, you know, and I don't want that to be my parents. Ideally, I wouldn't want it to be my grandparents, and I don't want it to be any people close to me, right? And so I think that right now it feels like somehow extra urgent. And I know that we're not the only generation that thought so. Many others thought that they were like close to a takeoff or like an evidential collapse. But somehow it feels like extra prescient these days where I didn't feel like it was that urgent earlier because I just didn't think that the upside was so immediate or something, you know?
Yeah. It does feel like a lot of these pieces are coming together quite quickly. And if we steer well through the next 10, 20 years, then we're in a very positive outcome scenario.
Yeah, it will always take longer to get these technologies like fully realized and actually accessible to everyone and, you know, actually create like a society that can adopt them and have a regulatory system that can like wave them through when it's time. So, you know, like there might be this other bittersweet moment of like, we have it in theory, some people are already getting access to it, you know, to like, we have a world that can accommodate these technologies. So I think that is definitely also a problem for the future that we have to deal with. Yep. But in general, there shouldn't be anything stopping us from kind of like really uplifting ourselves in the next 20 years or so, if we make it through,
Yeah, touching on a couple of things that are interesting. One might be, what is the kind of policy and regulatory landscape that thinks about these agencies like the FDA and others is very preventative in terms of, hey, stop certain harm from happening that one person is causing on another. And they're not really well structured to think about global natural harms in the same way. I tend to describe it as, unfortunately, we've put the FDA in this like really difficult position where they have to play this trolley problem of they pull a lever and run a clinical trial and end up accidentally causing the death of 1, 5, 10 people or like 100 people in a trial. They might get the cure faster, but then they did that, versus if they don't do anything, then like millions die from that preventable disease. And unfortunately, because of how we structured it, our society holds the FDA responsible only if they pull the lever, but not if they don't pull the lever.
Yeah.
And so it's this like really difficult game theoretic situation where we're not holding our systems accountable to the totally preventable deaths that are happening from natural causes. And like that is like just leading to gigantic volumes of death and harm.
Yeah, I think you can't optimize or hold people accountable for what you don't measure. And so making it very legible what the trade-off actually is and the opportunity cost, that would be good. And there are a few people that are trying to do that. Like, I think his name is Andrew Scott at the London Business School. He's trying to basically create an extrapolation of how much economic growth, how much productivity, how much societal benefit, how much human life years are actually lost by not having aging technology sooner, because it's staggering, right? We're able to just increase health span of people that are currently alive but are retiring early because they can't work. So he's trying to basically put numbers to this and just model out what the actual opportunity cost is of like not letting aging interventions come to fruition sooner. But then the additional thing would be to do that for a specific treatment, intervention, medication to try to get that counterfactual going, and then hold the FDA accountable for if you had accepted this, or like if you had waved it through just like 2 years earlier, those are the amounts of lives we could have saved. This is the quality adjusted life years that we could have enabled, and this is the economic cost that you caused, or whatever it might be, like things like that. So we just need to put numbers to these things, and we need to not only put numbers there, but then also use them to hold the FDA accountable, because otherwise we have this kind of tyranny of the minority of like these very legible, horrible cases where we still have the other horrible side of it that we have just accepted.
And it's gigantic.
And it's gigantic, yeah. And many people are suffering from it, but somehow we think it's normal.
Yeah. There's like a tyranny of normalcy that the world is always under, where like we just are somehow blind to the constant harms and terrible outcomes that are just normal, and we don't really think of them as strategies in the same way.
Yeah, because I do think it's back to this like level of psychological safety, right? Like actually accepting how terrible it is, and like having common knowledge that other people also know how terrible it is makes it even more terrible. And so the cope is just to pretend that it's all fine and that there's something graceful and wonderful about it. And, so I think unless we make the types of technologies that could prevent some of these like aging states so likely and so near within our reach that it would be ludicrous not to flip over to the other side and accept the psychological cost, to accept that the current state is bad, because now you have this other thing that you can flip to, and where those things are working, and you can actually just defect from the normalcy and deathest side to the other camp and have a strategy that works for you. I think we won't get everyone until we are able to do that, because it's just too costly psychologically for people to accept how horrible it is that we haven't solved this yet.
Something I think you're amazingly good at is understanding the depths of all these like incredible problems. And yet you're one of the most hopeful and bright, and you're filled with like all these amazing warmth and love and excitement. And I wonder how you individually kind of like navigate this landscape, and how you both fill your own life with the excitement for the possible and such like a force around you, both in the Foresight community, but beyond. You sort of like bring this energy of this set of problems is solvable. We're going to figure it out. Here's how we do it. Like, let's chip away at the problem, and we're making progress. And it's, first of all, it's great that you do that. Second, how do you navigate it, and how can you like inspire others to do that too?
Well, maybe partially is because I only have dangerous half knowledge of how complex and horrible the problems actually are. I think people in those specific fields are often just like, it's actually very tough day to day, so I'm not grinding away in a lab every day. And so it's easy for me, I think, to be more hand-wavy about that are like almost like Pollyannish naively optimistic. I do want to acknowledge that fact. On the other hand, I do think that many of the problems that seem insurmountable right now, I do think that in theory there are solutions to it. And so it's really just kind of like a question of like, are we going to do them or not? And there's nothing, like in the laws of physics that says that we can't do them. So I think that, you have to live like in the world in which it matters what you do, like conceptually, because if you live in the other world, then you've already lost. So I think even if the chances are like small that individually I or collectively we have an impact, the other world is just not like a non-starter from the get-go just because there isn't really anything to do in that world, right? So I think once you have accepted that, okay, maybe the chances aren't 100% that we'll make it through, but I'm still going to try, then I think you've kind of dealt with the fact that it's not going to work. And then you can kind of forget about that fact and just focus on like the worlds in which it matters what you do. And I think to some extent that also aligns with like, yes, I worry a lot about the risks. I worry gravely about the risks just because I think we're so close. And because even if we just progressed civilizationally as we already have, we have a really great future ahead. I do ultimately think that the biggest danger to that is an existential risk or something that would just curtail kind of like marginal revolution on which we are already on. Because yes, we've talked about all these amazing, like scientific advancements and how amazing they could propel us into that future. But ultimately, even if we just didn't kill ourselves, civilization is making progress in the sense that lives are getting longer. We are solving many of the diseases. Like people are generally better off along the way. We're generally more peaceful, more or less. So I think ultimately the existential risks are so damning because we are already on a good track. Even if we don't develop all of this sooner, it might not benefit you and I if we didn't do it. But nevertheless, like I think we are on a good trajectory of civilization in general, especially compared to our past. So existential risks are, I think, a big concern. But then again, I think the attitude towards them is also, well, we could either try to slow everything down, not do anything, or, like get very bogged down in doom. But there are a lot of things that you can build in this like differential technology development mind frame. So even if you think that the risks are really there for specific technological areas, there are often specific things that you can be advancing first. For neurotechnology, I hope that we don't just advance very advanced neurotechnology, but we also have a mindset for privacy and for security in mind. Like as we build these devices that have read and write access to our brains eventually, like we need to build really good, ideally like encrypted data provisions for neuroscience, like maybe some kind of like real object level capability framework for the neurotech devices so they only have access to what they actually need, things like that. So we need to build technologies always with a mind to the risks, I think, in mind. But that shouldn't mean that we shouldn't build them. It just means that we have to build them carefully and maybe sequentially. So I think usually even if you accept that there are risks, there's still things you can do productively, even in that world. Yeah. And then lastly, I think it's just generally an amazing time to be alive, at least for those that are like fortunate enough to say so. And I don't think that was always true, or at least I remember feeling so cut off from the future in Germany. Like I had a great life. I grew up really well. I had a wonderful childhood and very loving parents. So there was nothing wrong in my childhood, but there was still this yearning for the future that I couldn't really satisfy or something, or like a craving. And then I think I'm just so grateful to be in the Bay Area and having been here for 10 years, being now much closer to where the future is being built and how it's being built, and just be having a tiny seat in the front row. So I'm just generally quite grateful that civilization, we're at a level now where those things are seen within reach. I'm always reminded of Petrarch, who I think lived just incredibly long time ago and was trying to write a letter to the future. He was one of the first futurists and was writing you in the future, you will see amazing things and you will actually, develop all the science and technology that I can just not even fathom right now. And, we from the past, congratulate you for that. And he was just writing at a time when none of this was possible and writing a letter to us future beings now. So I think to some extent, there's this level of gratitude, to just be around right now, where many of these things that will be define the future and whether there's a future at all are fought out in front of our eyes. And then also having a front seat at it, in the Bay, it's just I think an amazing ecosystem here that I'm just so grateful to be a part of. So I think it's kind of hard to be very pessimistic these days, in the sense there's just so much amazing things happening all around us by many of the people that, you and I both know, but also in the broader just society.
Also, the internet was this amazing force for diffusion. So beyond just the Bay Area, that we sort of grew up with the explosion of the internet enabling this conversation to reach everyone. Previously was just housed in a few labs, in a few organizations, in a few cities.
I mean, that's how I found out about Cryonics, about Foresight, about like, that's just generally, I think, what gave you any hope, like, that, that like people are working on these issues. It's not just like, because before that, I think, like, mostly what I turned to was like philosophy. I was like, there's existentialism. This is how you can deal with the fact that you have high expectations for the world, but then a short life, and
very impressive that among the best the 20th century had to offer was existentialism.
Yeah, it's so like, it's cope too, right?
Super cope. It is like the biggest cope of all time. I have like a very strong beef against existentialism. I think it's like beyond coping, it causes people to stop striving for a dramatically better future. And I have like a countervailing philosophy that I describe as like Prometheanism, where you might be dealt a hand that might be very difficult, but there's an enormous amount of progress that you can achieve. And it might be risky, it might be difficult. Your liver might end up being eaten by an eagle along the way. But if you can harness the fire and be able to advance knowledge and science and technology, you end up uplifting everything. Maybe I can do this with Claude someday. Like, I wanted to write the myth of Prometheus, similar to like the myth of Sisyphus.
Oh, I like
huge
it.
Counterpoint, because it's a similar kind of story, similar kind of like Greek myth with a dark part to it, where like the hero doesn't necessarily end up in a good state, but the story is completely different.
Yeah, but I would say, I guess, like, it depends how you interpret it. Like, I mean, first, like, the myth of Sisyphus, which was written by Camus, like, it's still drawing on the old actual Sisyphus story of, like, Sisyphus was punished by having to roll up the boulder up the mountain, and then whenever he was up there, it rolled down again. He had to do it over and over again to eternity. And, like, to some extent, I think what Camus was pointing out is because before that, mind you, or like not before that, but like an alternative to existentialism is also nihilism.
Yeah, totally.
In the sense that like you could just believe that nothing matters in the face of having short, brutish lives. And so
or the
existentialism,
death of the universe.
Yeah. And so existentialism was like a little bit of a juxtaposition to that. Maybe not quite chronologically, but like nevertheless, like it was this notion that like, okay, like we have a life that is restricted in ways that we might not like, but nevertheless, you have to imagine Sisyphus as a happy creature or something. I think is the wording that he used.
Down,
like, he's like pushing the boulder up the mountain, but he's like doing this out of like the spirit of being human. He's like choosing the battle.
Crafts his own fulfillment through the effort and the act of pushing the rock uphill, and creates his own meaning. And this is where I think it turns negative. It's like if you push that really far, then the only thing that matters is the meaning that you come up with. And it encourages this almost solipsistic attitude where the height of meaning is just whatever you tell yourself and you come up with. And it encourages this extreme subjective perspective instead of thinking about the intersubjective that we have to deal with, or like the actual objective reality of like very large planet. There's all kinds of challenges that we have to solve. The sun is going to run out of energy at some point. There's death and disease all over the place. And you can have a huge impact today. And if you kind of like take the super existentialist route of like, oh, I'll craft my own meaning by escaping into literature or into the things that like I craft my own joy over, and I don't instead work on like the more pro-social things that contribute to the rest of the world or contribute objectively, you end up in like a bad state. So I think like definitely like seems like it was a needed step forward, but it also is, I can see today that a lot of the existentialism that lurks in the reaches of the kind of social consciousness inhibit a lot of people from taking charge of improving the world for themselves and for other people.
No, I agree. Like eventually, like, you want to break out of Sisyphus in the sense that like the boulder should stay up on the mountain.
Yes.
And then you want to build a civilization on top of it. Yeah. So eventually, like you want to have an impact in the real world. Right?
You want to go and like get the fire from that is locked away in the
exactly.
house of gods
Yeah.
and distribute.
Maybe you burn yourself.
Yeah. Maybe you burn yourself along the way, and it's hard, but like you figure it out and like you advance.
I do agree that that's better, but it's a spectrum, right? Like of things. Like nihilism is like on all the right, all the one end. Existential hope maybe all the way on the other, and then there's like different things in between. And
yeah, these are useful polls to pull the conversation and pull perspective and to inspire action.
Yeah, for sure. I do hope that more people are like empowered, I think, to actually have that mind shift, because it can feel like a little bit like, just like, oh, it's so easy to say, like there's so much opportunity and optionality for us already. Like, so of course, like it's easy to think that way, but I do think that like you can do that on all different levels, right? And like there's always like one level further you can advance yourself to, and another person that you can help, and another connection you can make, things like that. There's like endless amount of things to do that are like inspiring and also broadly helpful,
Yeah, and speaking of connections and inspiring, this is one of the things that I think Foresight is incredibly good at. As an institution, Foresight has been gathering hundreds and thousands of people over, I guess, 4 decades now, helping shape fields and identify bottlenecks and like the tech trees that we have to solve and the dependencies, and causing, kind of stimulating conversations, has constructed this connective lattice across different labs in academia, across different companies, across venture capital and philanthropy and society. How do you think about it? How do you build it? What you've been able to catalyze over time?
One secret was just the fact that Foresight was around for so long, and that there were these group of people that had like a mixture of characteristics. On the one hand, they were like quite optimistic about the future and like wanted to do something. On the other hand, they were not just like philosophers. There are a lot of transhumanists around, etc., that are just like kind of like thinking about how the future could look. No, it was like a group of scientists and technologists that were like actively working on the future. And then they were also like risk conscious to the extent that like people were actually like engaged with the downsides, but in this like very productive way, where the downsides didn't mean you couldn't do anything, but like you just had to like work on something responsibly, right? So it was this kind of like cool attitude towards the future that was like not super polarized or something. And then I think many of these folks are kind of like have just stuck around and are still kind of like inspiring that vibe. And then many new folks I think along the way are like thinking similarly, like just very pragmatic, optimistic, but like, build oriented towards like the futures that we want to build. And so I think those people are ultimately the ones that you want to connect with each other, because whether someone is doing that in neuro or in nano or in AI, they often have this other shared property that they care about other fields and domains. So I think one thing that I also liked about Foresight is that it wasn't just like a one technology shop, it had this like deep ambition for the future. It was not technology agnostic. It had definitely had a few bets, but generally speaking, like the future is not built on one day, not by one org, not through one technology. Like we need to kind of like think about and build technology in tandem with each other. And so
it's kind of like a university in the original sense of the word, where you're bringing together all the different people from all these different fields and enabling them to create a space for them to talk and discuss these ideas. And not like traditional modern universities where as a faculty member, you're supposed to swim in a particular lane and you occupy a fixed spot and you have to teach a specific set of classes and only do research within a specific frame, and you have to kind of advance your field in a particular way, and you can't step on the toes of the other people in the other fields nearby, or like you can't say things that are like too crazy or too out there yet. And so in a way, like our universities, who are supposed to be the places where we are able to explore ideas fully, somehow have become more conservative and more shut out. And then the scientists and technologists and builders have to find these other outlets to talk about these things.
I mean, I totally agree. I remember, I guess in philosophy, it was a little bit more. I don't think I had that problem that much in my university, but definitely what I hear from other experiences, it was pretty stark. I do think also that like there has just been a growing movement of orgs that are picking up the slack and, building like focused research organizations left and right, or like other fantastic nonprofits that have like come along in the past, I would say, I mean, very much so in the past 5 years, but like maybe broadly over the past like 10 years or something. So there is now a space of orgs specifically for like individual areas or something, where there is now like a much more of an ecosystem that I would have liked to see maybe early when I came to Foresight. So it's definitely, I think, we're in great company these days. And like one thing I think that we're trying to do is also connect these different people, organizations, and projects to each other, because I think sometimes, like they have their own communities, but like there are so many pieces, I think, that people are building in parallel with each other. And so having complementarity on the one hand is great, but like having different orgs, people and products be able to collaborate across VC, philanthropy, academia, engineering, open source, company. Like I think that's something that I really like. And often there's like a lot that these people want to do just because they're like so inspired at like what the future could bring. So it's on the one hand, I have big imposter syndrome within this community, but on the other hand, it's just like a very inspiring, I think, group to be a part of. And it's just kind of inspiring to see just how much, I mean, like you must have seen this too, right? Like over the last few years, like the amount of people that are coming out of the woodwork, building amazing shit. I mean, we've just seen the Midjourney announcement, right? Like, wow, that's now a thing. Companies are just like using all of their funding to like create this entirely other technology that was not in the original plan, but they're just like, yeah, we now have the funding to do this, and we're just going to revolutionize science. Like things like that. It's amazing, that this is now a thing that, and of course they didn't have much VC funding, so that was easier to do and just to decide. But in general, I think it's a great community, I think, right now, and it's growing rapidly. And so, I don't know, there's just a lot to do, but also there's now a lot of people that are coming and doing it.
And concretely, talk us through the range of programs. Like you do workshops, you have a range of prices, you have a range of events that gather the community, you have online seminars and network connectivity structure. Like how do you kind of like upkeep the community, or like what role do these pieces serve?
Yeah, I guess you can slice Foresight like one or two ways or both ways. Like one is like by the focus areas that we have. And again, there's a lot of overlap between them, but like there's the secure, like, decentralized cooperative AI area. There's the neuro area. And like within those areas, it's mostly really the frontier stuff that we're interested in. There's the longevity, long bio area, and there's the nano area. And so often you can initially you have people coming in through one of these buckets. But then oftentimes, once they're in a bucket, they're just like, oh, but I'm also really interested in neuro. Let me go over here. And we totally allow that and try to encourage people to do so. And then what is happening in these domains, it's usually like a mixture between the programs that you mentioned of in some areas, prizes are still a good idea to encourage a competition of ideas about how to do an ambitious scientific feat. In some areas, grants are a great idea because of a few approaches, but you want to actually encourage a lot more innovation in those. So there's a lot of grant giving, probably the biggest one, expenditure based. And then there's the workshops, which are mostly field building activities to the extent that sometimes there isn't really a field yet. And so just kind of giving prizes or grants would still not really create an ecosystem. You actually need to bring people together over a period of many years. In many of these areas we've done workshop now, or I've done workshop for 10 years. Foresight has done workshop in some of these areas for 30 years every year. So there is a growing cohort then that people can kind of come back to and hire from and coordinate around. And then for those that are not in the Bay Area, there is the virtual seminar platform, which is mostly just trying to create virtual Schelling points around these technologies where people can present new research and just try to create more connective tissue around that. And then the Vision Weekends are these big events where we try to bring it all together and just have these festivals where we celebrate scientific progress. And one bit, I guess, that we added this year because it's our 40th anniversary, these AI nodes. So rather than just supporting folks to fellowships or grants or something, what we've really focused on a lot more is actually in-house support. So oftentimes these people really actually want to be part of a physical community and actually build amongst each other. And that's becoming, I think, more and more important, not less. And because not everyone's in the Bay, or nor should they be, we have one now in the San Francisco area and then one in Berlin. And there's now a lot of interest on launching these nodes, these collectives with funding and other support structures in other areas too. Maybe each city, for example, Boston could have more of a biotech vibe, and they could all pick different specializations. And I think the most important part there that we have started doing, which is also possibly the most difficult part, is to provide in-house compute to projects. And so on the one hand, that seems like a totally mistaken effort, because why would you build your own clusters if you can have access very easily to many of the hyperscalers and data center providers that you have? But on the other hand, I think future-proofing your efforts maybe almost not necessarily requires you to build up your own cluster, but you should at least consider it, because we already see compute prices. I think they have doubled or something since last year, or at least in a very, very short time, depending for specific use cases. But compute costs are rising. I think they're going to continue rising now that the race is on between the main frontier labs. Eventually, they might.
For a while, yeah.
I mean, unless we have some real breakthroughs, I think for quite a time.
Once we get recursive self-improvement, factory tape out of just tons of chips and data centers.
But then we might still want to use a lot of scale. Maybe if we actually if new model architectures might pan out that are massively more energy.
One good existence proof is, the brain runs on less than 30 watts. So we should be able to figure this out.
Yeah, long term, for sure. That would be a goal, and it would be sad if we didn't make it work, right? Yeah. Otherwise, I think all of space could be filled with data centers, and it's just going to be very difficult to do anything.
It's definitely pretty excited that we started building a Dyson Swarm in 2026 and didn't wait until 2036.
Sure, why not start now? And I do think many of the problems, for example, space exploration or space manufacturing, space development, but also energy, like solar energy, other forms of like clean, green energy might just be accelerated through compute, the need for compute. But I think in general, like it's unclear to me whether independent projects and AI for science efforts will have access to the compute that they need on the long run. And I'm not just saying like, you want to build something that the government might not approve of and it eventually might not get compute. I'm mostly just talking about like, we've seen what the US government did with Fable, right?
Yeah.
And so that's a model provider, but like it could do that with data centers that are based in the US. I'm not saying like I have of any like intel that it's going to happen this year, but eventually the US government will wake up to, how critical compute is. They already arguably have. And so I think if you want to be like sovereign and independent and actually like have a future-proof strategy, you need possibly your own compute. Or at least it's a theory that we have. And like, it's not that we're trying to be competitive with the big labs.
The sand into chips yourself.
Yeah. Eventually you have to start grinding. No, but like, I think it's also kind of fun, to get your hands dirty and like figure out like new ways to do community oriented.
Well, certainly we can figure out nanotech correctly. Then yeah, we can mega decentralize the ability to construct all this stuff.
Yeah. And then you have like very local energy production and energy consumption eventually, right? Like all those things kind of go hand in hand to some extent. But yeah, it's kind of TBD whether that future will actually be necessary in which you have your own compute. But it's at least like a hedge.
Yeah. Has Foresight done any estimations on the cost structure of a nanotech program?
There are some. And with Foresight, I mean like people that we have asked, like most of the people you already know, like Adam Oberstone, et cetera. Like a few people have tried to do, cost extrapolations. But I think mostly what people, I think, are trying to estimate, and I don't remember the exact numbers, but it was not necessarily like actually molecular manufacturing would cost or producing that, like a machinery that could do that, but like what is molecular 3D printer or like some kind of like some intermediate step that could then inspire more capital to flow into like the longer routes. And so I do hope that eventually we'll get that funding. I'm not saying Foresight should get the funding. I'm saying generally as a field, there is enough interest and incentive again to like think about nano because that will become the main bottleneck. But
I feel like the US needs to appoint Adam as the chief roadmapper.
That would be wonderful. I would totally vote for that if I could vote in the US. Yeah, I mean, I think he has his hands in many of the areas that people care about, like not just nano, neuro, of course, and to some extent bio. And so that would be wonderful. Not just roadmapper, but also like instigator, right? Just like throws all over the place. And I guess to some extent, like, the US government is taking some hints recently, like X labs and like, or the tech labs, I guess how they call it.
The NSF labs, the new tech labs are FRO inspired.
Yeah, so that's great. We also have to give credit where credit's due. That's pretty awesome.
And certainly Adam's thinking was shaped by ARPA and DARPA and like,
of course.
It's all remixes.
It's all remixes, but I'm just glad that these are happening. And then of course you see amazing efforts like ARIA, that are yet again like remixes of the ARPA model. And I just think that generally we need a lot more of those.
Maybe on prices specifically, like I think Foresight has had a bunch of success with prizes in both identifying and recognizing innovations and people who then went on to do like a bunch of like great work. Like what are some of those stories?
Okay, so let's see. On the nano side, at least, we gave 2 Feynman prizes relatively early that then, I think it was in one case 9 years and in the other case multiple decades later got awarded with a Nobel Prize. And I mean, the latest one is perhaps interesting just because it was awarded to AlphaFold and to David Baker in the same year. David Baker was one of them, basically, where we tried to like award progress in nanotechnology early, perhaps like strange approaches, like Baker's case, he's now working on like a Rosetta or like a real computational AI approach to make progress on like protein engineering. And so we tried to just be early on some of these fronts. And in Fraser Stoddart's case, who was the other Feynman Prize winner who later on went to win a Nobel Prize, it was like really like building these very functional molecular machines where you could actually like really like distinguish a function. They actually look like little machines, Not that the ribosome doesn't, but yeah. So there were like some of these kind of like good early picks, like, and I think now, especially that it's our 40th anniversary, I'm diving again into our archives. And Christine Peterson, who co-founded Foresight, also coined the term open source in this like, I think it was 1998 effort to packaged the idea that software should be open, should be editable, should be modifiable, rather than should all be patented and locked away and not interoperable. Try to like package that idea, because at that point that was a new idea and it wasn't the way that software was going. And then now look where we are with open source, right? Like it's like the main way of doing things. Not saying that Christine had like anything to do with the way that the field turned out, but I think sometimes the naming and like the early conceptualization, really like trying to put something on the map can have an impact there.
Our ability to describe, name, refer to things advances our capability of doing a thing. Examples of this include like mathematical notation. Like once you develop like the right mathematical notation to do certain kinds of operations, a whole world opens up. This is like why, I don't know, Leibniz and others were so influential. It's just like figuring out that notation structure.
At the end of the day, like these words or terminology are like abstractions, and then through these like abstractions you can build a higher level abstractions, and it's like compose like knowledge in a more packageable, like mimetically.
The computer can now handle it better. Yeah, totally.
So I think that naming things are definitely important. I think ultimately,
and popularizing it and all that kind of stuff.
Yeah, I think the popularizing bit is definitely, I don't know, I think Foresight is always like a little bit maybe too early, it's definitely like we're not a very popular organization.
It is named Foresight.
It is named Foresight.
Not After Sight.
That's true. We're not the Hindsight Institute.
Hindsight,
No.
That would be great to start on April Fool's.
There is actually that organization.
That's great.
Yes, there is something called the Hindsight Institute, and Christine is involved with it. And it's a hilarious joke. They have business cards and they hand them out at Foresight events.
That's fantastic.
It's all very self-referential and hilarious.
That's great. We've heard a little bit about you as a kid and being inspired by certain ideas. What shaped you? Who inspired you? How did you develop? There's a lot of people out there who grow in lots of different ways, and so hearing individual stories can be super helpful.
I definitely grew up reading a lot, because also there wasn't all that much out there yet, at least early on, right? Reading a lot of philosophy, like Nietzsche, and then a lot of existentialism. And then I was like, this is not good enough. What else is out there? Then I kind of switched into early transhumanism, extropianism, cosmism, and some other just like early versions of less wrong, what were they called? Arbitral, and some of the early Scott Alexander writing. And there was some early futurism online that was very interesting. Lots of sci-fi. Once I discovered it, I actually discovered it quite late. But yeah, so I think like reading and then the internet was like, I think it's just a big level up, and that's available to everyone really, right? And then I had a great philosophy instructor and teacher, and then at university I had a few courses that I just really loved. Like I genuinely had a great, I think I loved my school life and I loved my university life. I actually had a really good experience in my educational system. That seems to be very rare, but it happened. I mostly grew up a lot outside. I had a dog that I mostly spent time outside with, I guess. Like through university, I think I really dug deep into philosophy of AI. That was my, the thing that I did my Master of Science dissertation in, and then read a lot of classes, for example, from Jonathan Birch, who wrote a recent book, The Edge of Sentience, that just came out. And that's a lot of different types of minds and how they work, and had a big kind of mind emulation, or different types of minds investigation angle. So there was just some really interesting classes around actually at my university. So that was awesome. And then I discovered Foresight eventually through the internet and those weird corners. And then eventually I cold emailed them and I asked if I could volunteer for them. And then they asked me to come over to the Bay. I had no clue where that is. I actually thought at that point the Golden Gate Bridge was in Los Angeles, and I didn't really have a differentiation between San Francisco and Los Angeles in my head at all, and was very confused when I ended up here. But then I went to my first Effective Altruism Global, and back in the days there was just all kinds of amazing world improvement ideas and projects there. And there were so many quirky Bay Area events at that point already, in so many communities. Less Wrong was already a big scene then. And yeah, at that point, it was just a big frenzy here of people that were all working on interesting science, world improvement, and big ideas projects. And so it felt like a breath of fresh air to come here. And at that point, longevity and AI were my two biggest focus areas. And there are both people here working on that, very much less so than now, but definitely already more so than in any other place in the world. So yeah, I guess that's it. And since then, I thought I would stay for 3 months, but a decade later, I guess I'm still here.
So you came initially for 3 months and you just kept extending?
Yeah, I kept extending, yeah.
That's awesome. And how do you think about how the rest of the world has developed over time? I think Foresight has inspired a ton of people around the world, and you also help connect a lot of people around the world. Is it a lot of talent flow to the Bay Area, or have you seen a lot of activity stay in other places or flow between other locations?
I mean, it's definitely a lot more exciting to go to Germany now than it was before. And to go to the UK, it's just kind of awesome. We just had a Vision Weekend in London and it was amazing. So I do think that many of the other pockets where at least I didn't have a community of like minds back in the day, neither really in Germany nor really in the UK, there are now just, there's things happening now, like there's communities now around these types of issues. And also, like, I should say, incredible talent and incredible creativity. And it's awesome. I definitely think that there's a lot more going on now than there ever was. And at the same time, I think maybe during COVID, there was a move away from the Bay to some extent, but like many people are coming back. And I've never seen the Bay Area as kind of popping as it is right now. And whenever I try to go anywhere else or fly anywhere else for an event, it's a real cost to not be here for like a few days or a single weekend, because every single weekend there is a conference here or a meeting here or a workshop here that is like expressive of at least what I care about. So it actually takes a lot of willpower to leave these days. And then, of course, what added to it is I had a child. So that makes you a lot more stable and a lot more stationary than before. But it also inspires you a lot with hope for the next generation and for what's to come. And definitely with a lot more incentive to get the future right. So
do you think a high quality conference workshop type environments is just so rate limited to happen digitally until like we get uploading right? Or do you think we're going to figure out some way of having that kind of experience online?
I don't know if you can have it online. I know that like people are definitely trying, and there's some great, I think there was a Funding the Commons that was online that was really fun, or at least like a part of it was online.
The first one was online.
Yeah, see, that was really good.
Had some of the best
talks
so far.
That was awesome. Online. I remember that. That was really good. So yeah, people are doing that. Also, there are many organizations.
Right after COVID, so we had some excuses there.
I know. So COVID, I think, actually helped us also get global, because suddenly everyone was online, and through that because we did twice a day online programming during COVID to catch both time zones, I guess both the European and US time zone. We gathered a huge global community. So I think COVID was really the time where we went from a Bay Area org to a global org. And now most of our staff is not here. We have a node in Berlin. We're trying to have nodes elsewhere. I'm not saying everyone should come to the Bay. It's also super saturated. And we are actually trying to also create other dependencies to decentralize, or at least create more connective tissue between places. And then there's a lot of amazing other events, right, that are happening. Like you guys are hosting amazing workshops, like the Neuro workshop the other day was awesome. I wouldn't have wanted to be anywhere else today than in Montauk. So I do think there is a lot going on as well. It's just that there's generally a lot more happening now, And every once in a while, I do think that it would be kind of better to not live here, just because you get more done, because you're not so distracted by all the social stuff that's happening all the time, But ultimately, that's also how you hear about what's happening and stuff. So
culture is a big part of innovation.
But I do think you can actually get most of the intel from Twitter.
Yeah.
There's not very much that is said in private channels here that people don't also say on Twitter. I think often there's definitely group chats that are a lot more exclusive, but in general, I'm always pretty amazed by what you can learn on Twitter.
What other books shaped you, or you love, or you think are very compelling that people should go out there and read? Or
well, there's Beginning of Infinity. I think that's just a book that should be required reading.
Yeah, I think that is the best philosophy book.
I think also the David Deutschian way of thinking, of really just trying to figure out that nothing that isn't actually physically impossible should be out of reach long term.
Not forbidden by the laws of physics.
Yeah.
It's possible.
Then it's possible. And, there's also some interesting theories of the universal constructor came out of that, et cetera. He's just a very brilliant person in general.
And his conception of knowledge was incredibly formative for me also. How to think about memetics and knowledge structures, and the only thing preventing you from doing something is knowing how.
Yeah.
Constructing the ideas and the idea space and so on.
I don't think we've fully grasped yet all the ideas that are in this book.
We're in the instance of realizing the outcomes of this new way of thinking.
And I think the interesting thing is that David Dirt is not very AGI pilled at all. So that's I'm still trying to come to terms with that.
I think he's AGI pilled in that he does think we will construct AIs eventually, but he has been negative on the work so far. Yeah, I think there is a strange aversion to digital minds being able to have the same level of creativity that organic minds. But I think he's about to be proven wrong on that.
Well, maybe one day I'll just understand him, and I know actually that he was right in some foundational sense that I can't even grasp yet or something.
Yeah, usually there's some crux assumption somewhere that yields this outcome.
We will definitely find out one way or the other soon, I guess. I think another one is just what is it? Surely You're Joking, Mr. Feynman. It's just such a fun read. It's just so easy to understand. And you get this kind of download of this crazy, wonderful mind that existed and just like did things in the world. And so that's just an amazing book in terms of like how you can be in the world, still be brilliant and functional, because he's obviously brilliant, but he also just had a very fun way of going about life. He was incredibly curiosity driven, and most of the time you weren't sure if he was joking or not, So that was an interesting read. I mean, there's so many amazing sci-fi books as well, but I almost feel like Permutation City, just nothing really cut quite like it for me. So I guess I did like the Culture series. It was more space opera, but it was trying to draw out how can a kind of post-scarcity utopian society live. Player of Games was about like, what games might they play? How can they find meaning in life and stuff? So there were some interesting aspects in that too. I think for me, Greg Egan is just kind of untouchable.
Yeah. What is your optimistic vision for the future?
I ultimately hope that we can develop all the science and tech that we have discussed, from advanced nanotechnology to rearrange like the physical world in a way that is like both sustainable for the biosphere and the planet that we inhabit, but then also to create amazing structures and devices and a physical infrastructure that could lift us off this planet and that could make us really like explore what is out there. So I think the hardware component is actually kind of important. The other one, of course, that we discussed is the neuro layer of like, you actually can't go out very far unless you are a digital mind. So we do have to get that right eventually if we want to see some parts of the universe. And then, of course, you don't have to go out that far into the universe. You can also stay in a very rich virtual environment right here on your local machine. So I do think that neural layer is amazing. The kind of like base layer for all of that is, I think, individually like human longevity and actually like being able to have a future at all. So I think that's what we absolutely need to get right for our individual ability to like benefit from any of this. And then on a civilization layer, like we do have to get AI right enough that it can benefit all these other fields, and right enough to not, lead us into a destructive nuclear war, bio-risk scenarios or cyber risk scenarios that can take out a lot of civilization, or at least set it back by a lot. And we don't want to have like a runaway AI that either can destroy the world itself or that is sentient and suffering, things like that. Those are like the necessary condition of the ingredients that we need for the future. And we need to kind of arrange them such that they can benefit each other, but not that they do destroy humanity. And then I think generally, what types of society do we want? Well, I ultimately think that this may come from my philosophy background, but like on a meta ethics level, I think it's going to be very tough to agree on one path to go. I think we both agree on a lot, but I don't think we'll actually want to live up in the same or like in exactly the same utopia. I think there are a few people, like you're probably one amongst them, where I'm like, okay, I would actually feel like more or less comfortable in handing you the stick to the future. But ultimately, I think that's definitely not true for everyone. And I think this notion that we often had for alignment of like, we want to create a coherent, extrapolated volition, basically like figure out what humans would want if we thought longer, we're more the people that we wish we were, we're more rational, we're smarter. Like, I just don't think that exists in the sense that people have different intuitions to situations. They're either genetically enshrined in them through various different genetic variants that we have, and or they are kind of enshrined us through our upbringing. And so we actually see the world mimetically, right? Like we actually see the world differently, right? And usually we think that's a good thing. We value diversity. And so I don't think we're going to agree on one future path. And so we need to have a future that allows for pluralism, that allows for diversity of viewpoints, that allows for many different ways to live. Some want to have ultimate morphological freedom and create very different substrates for themselves and look very different. And some will just want to, have their garden and be the crochet futurists. And so I think we need to have a future that can allow for both. And so we need to have a future that can have peace between them. So ideally, like they respect each other's boundaries. They don't interfere. There's no war. There's no mimetic interference, no violence. And then on the other hand, we also want futures in which those that actually do have a more or less aligned vision on some part of the future can cooperate much easier and can actually go out and build stuff together and just kind of like align on the ways they need to create futures that are, again, evaluated each better than before by their own standards. And so we don't really actually need to agree on something. We just need to agree enough to collaborate on some specific thing, and then we can go out our merry ways again. So I think ultimately, hopefully, we can have this like Paretotopian vision of the future kind of come true. And I don't think much is stopping us. But I do think it requires like a level of physical safety, abundance, and just kind of like level of living that allows at least everyone to like flourish in their own way and actually go out and live their best lives, to each by their own standards.
Wonderful. Thank you very much.
Thanks. That was very fun. And I should also say, really, not just thanks for the conversation, but you and Protocol Labs in general, I think, have been such an amazing force for good in not just, no, I actually really mean it. Like, I think I remember, like, before I actually knew you personally, I've always like followed some of your writing. I was like, well, they're doing such interesting work. How's this like company, like doing so much interesting work? And I think ultimately companies and efforts are like expressions of some of the people that like instigate them. And I think you've like just had a really long reaching breath for the future, like an interest in the future, like an obsession with it, like a craving for it. And I think it showed in the way that you build the Protocol Labs, but also the entire ecosystem around it. And then the big neuro effort now is just, I think, great to see. I wish more companies did things like that. It's very similar to what Midjourney did, right? Of just like, this is what we want to bank on in the future, and that we're just going to go ahead and do it. And so it's been awesome to see, and the collaborations that we've had between PL and Foresight, and how, we've like partnered on so many of the efforts, has just been really fun. And so I hope that there's a lot more of that out there, especially now that PL's like more of a network structure. There's probably going to be lots of different pockets of that popping up. So it's been great to see.
Thank you very much, Allison.
Yeah, that was very fun. Thanks.
I hope you enjoyed this episode. This is a new podcast, so we need your help to get the word out. Please like, rate, and subscribe on your favorite platform, and share it with people you think would find it interesting. Thank you. See you next time.